While the war in Ukraine rages on, both sides have been steadily improving their arsenal with newer, shinier, and more effective battlefield technology. However, there's another battlefield that may determine the outcome of this war: money. Taking out enemy vehicles and equipment was becoming more and more costly, as missiles require millions of dollars to manufacture and transport, and single-use equipment proved to be a financial burden. But that changed with the introduction of modified commercial drones. These devices can cost only a few $1,000s to create, but also cause millions in damage, and there hasn't been a cost-effective way to fight them, at least until now, and it involves the stuff of science fiction: lasers. The US has started showcasing its laser-based weapon, which aims to reduce the cost of taking down a drone from potentially tens of thousands of dollars to just $3 to $10. If the weapon proves to be effective, it could practically change the entire balance of drone warfare. But first, how have drones become such menaces in war? Over the past few decades, the armies of the world have become increasingly reliant on technology rather than sheer manpower. While the most powerful nations, at least militarily, still have substantial militaries to back up their geopolitical influence, regular soldiers might not be in the spotlight for much longer. You see, even at the turn of the 21st century, the US has shown the world what it could accomplish with drone technology. While the development of drones in battle started during World War I, the mid-2000s saw the successful deployment of the General Atomics MQ-9 Reaper deployed during the War on Terror. As a hunter-destroyer drone, the Reaper was responsible for precision strikes deep into enemy territory, leaving the opposition with no real way to counterattack. And as a bonus, the Reaper was operated fully remotely, with the pilots being hundreds of miles away. Of course, the Reaper had a huge issue that made it impractical for many militaries: a prohibitive price. It was estimated that one Reaper drone cost up to $32 million, a ludicrous price to pay for most countries. Over time, the presence of military drones waned, with the Reaper's high price tag and single-strike capabilities not being exactly what the world needed at the time. This gap in technology was compensated for somewhat by the newly made kamikaze drones, a single-use long-range drone that would deliver an explosive payload, destroying itself in the process. These designs include the Iranian HESA Shahid 136, a type of loitering munition that Iran has sold to Russia to use for its own purposes, such as the war in Ukraine that started in 2022. Shahid 136s were estimated to cost somewhere between $100,000 and $200,000. But it's suggested that Iran might need as little as $50,000 to make one. But there was another type of drone that became increasingly popular over the last decade: commercial drones. Unlike military drones, commercial drones were designed for specific, non-combat purposes, ranging from taking photos or videos to delivering items or carrying tools. Perhaps one of the most famous examples of commercial drones that have taken off, pun intended, are the drones made by the Chinese company DJI. According to Drone Industry Insights, and reported by CNBC, DJI drones currently account for more than 70% of the global drone market worldwide, and that's despite being blacklisted in the US. The main advantage commercial drones have had over their military counterparts is their affordability and ease of modifications. A single DJI drone can cost as little as a few $100s. More specialized drones, such as the DJI Mavic 3 or the agricultural DJI Agras line, cost from $1,000 to over $10,000 per unit. Still, that's considerably less than the Shahid drones. But why have commercial drones suddenly entered the spotlight? Well, the war in Ukraine has rapidly accelerated the usefulness and improvements made in commercial drones. It turns out that you don't really need a $200,000 drone to make small-scale surgical strikes relatively near your front line, some 20 to 50 miles away. Instead, you can take a commercial drone, outfit it with a larger battery, and then attach an ordnance like a bomb, mine, or artillery round to it. After that, you can let the drone fly loose, with the operator maintaining practically real-time control over the small device. Drones like the DJI Mavic could carry small grenades or bombs with a maximum payload of a few pounds. However, the larger agricultural drones could be retrofitted to carry up to 50 pounds of ordnance and batteries. These attributes have made them particularly deadly on the battlefields during the war in Ukraine. The Ukrainian army has been noted for making especially good use of commercial drones, enabling them to destroy Russian tanks or demolish fortified positions. Ukrainians have also improved on the basic agricultural drone, designing the so-called vampire drones that could carry 3 or more grenades for multiple strikes, or a large anti-tank mine for a greater area of effect. However, the Russian army isn't far behind in terms of drone usage. In fact, some Russian drone operators were so successful that the Ukrainian army had to launch specific operations to track them down and eliminate them. One such operator was codenamed Moses, a drone operator and commander who was directly or indirectly responsible for Ukraine losing 31 boats and up to 400 soldiers. When the Ukrainian military finally managed to take out Moses, it essentially allowed it to pivot into a counteroffensive against Russia, delaying the latter's offensive of the area by days. Of course, the success rate of both Ukrainian and Russian drones is abysmally low, with some Ukrainian battalions suggesting that for every drone that hits its target, up to 10 might go down before they manage to reach theirs. That's where the drones abuse their greatest advantage: economic efficiency. With the price of weaponized drone dropping as low as a few $1,000s, it's relatively cheap for either army to use drones as the first lines of attack on the enemy. But one of the few ways that drones are being taken down, through short-range missiles or anti-air defenses, can be prohibitively costly, with some of the more advanced and effective defense systems costing 10 or even hundreds of times more than the commercial drones. Using anti-air defenses only really makes sense, from an economic standpoint anyway, when taking down more expensive drones such as the aforementioned Shahids. However, both armies are practically forced to use them since there are no viable alternatives, and the damage a single drone could do can be significantly higher than the cost of anti-air missiles. A $10,000 single-use kamikaze drone taking out a tank that costs millions puts the drone operator on top, economically speaking. But that's about to change with the advent of the Locust Laser Weapon System, or LWS. The system, manufactured by the US company Blue Halo, is a truck-mounted, palletized, high-energy laser. The laser contains a separate targeting and guidance system to its left. The guidance system is almost completely AI automated. It allows the Locust to detect and track small flying objects, such as drones, from over 2 miles away. When the guidance system locks onto a target, the laser is powered up, creating a steady beam of high-energy photons toward the drone, concentrating their energy into a focused area and causing intense thermal heating. The increased energy manifests as heat. Given enough time and concentration of photons, the laser beam essentially melts through the drone. Depending on which part of the drone is hit or melted, there's a likelihood that the entire drone either goes up in flames, its control system shuts down, or its propellers are melted so it drops to the ground. Regardless of the method, the result is a non-retrievable drone, which is part of the reason why the weapon shows promise and why Russia or any other US enemy might need to readjust their drone warfare tactics. The laser system itself is practically platform independent. The box that houses the laser and its control system is roughly 7 feet long, 7 feet high, and a few feet wide. This allows it to be fitted onto the back of most military vehicles, and not just ground ones either. Initial experiments with the Locust were done using the Striker, which could potentially allow the system to be readily deployed and redeployed near the front lines, where the modified commercial drone activity is the highest. The testing, which was done in September 2024, showed promise not only with commercial drones, but also with even more dedicated military models. According to the specifications posted by Leonardo DRS, a defense contractor that's also worked on the Locust system, the Striker-mounted laser can destroy Group 1, 2, and 3 unmanned aerial vehicles. These include drones that have a lower weight than 1,300 pounds and can reach speeds of up to 280 miles per hour. The categories, which are quite broad, distinctly cover pretty much any modified commercial drone that's so far been used in the war in Ukraine. The Striker-mounted system utilizes a Doppler radar for 360-degree visibility to aid the tracking system. The head of the laser can swivel between -30 and +90 degrees, meaning it can strike targets below the horizon line or directly above it, creating a more effective and responsive weapon. If the system doesn't use AI-powered targeting, then the Doppler radar can be combined with its high-fidelity camera to aid a human operator. To that end, the system's camera provides FPS with a 3x zoom, including an eye-safe laser rangefinder for precise tracking. The acquisition sensors operate at 120 Hz with a resolution of 1280 by 720, covering both visible and MWIR spectrums, enabling broad-field tracking of small targets. The human operation is done via a controller. This allows the soldiers to quickly get acquainted with the system being used for tracking and targeting, greatly simplifying training. Essentially, the system's operating system is designed to make the user interface and control feel as similar to a video game as possible. This allows soldiers with experience in games and exceptional hand-eye coordination to operate the laser system expertly with minimal downtime. The version of the weapon that was tested in October 2024 was reported to have a 26 kilowatt laser inside the system. However, reports by Leonardo DRS suggest that the system can be tuned to have a variable power output as low as 2 kilowatts and as high as 20 in some cases. The increased wattage directly contributes to a laser beam with more energy, which either speeds up the heating process or reduces accuracy loss over long distances. But a big part of why the system is potentially groundbreaking for countering drone warfare is its price. The initial cost of installing the system onto a platform can be relatively high, with early estimates suggesting an $8 million price tag. However, once that's done, the laser actually accepts pretty much any electrical source with batteries, generators, or even shore power configurations for ship-mounted systems, all being viable choices. After the installation, the system can practically work without any additional consumable parts, apart from batteries or recharging the coolant system. Effectively, the entire weapon is powered by electricity, and the fact that it doesn't need much makes it relatively cheap to operate directly. Based on testing, the price of spending 15 seconds to shoot down a drone could be as low as $3. Of course, this price fluctuates depending on the actual energy source that's used and how long the system takes to destroy a single drone. With that in mind, the integrated cooling system allows the laser to continuously fire for 100 seconds at a quarter cycle. This means that after those 100 seconds, it would take another 300 seconds for the system to cool down sufficiently to be used again. As such, the weapon might not be able to completely destroy a concentrated attack that uses multiple drones. Since it would take roughly 15 seconds for a single drone to be struck down, a large-scale attack could get past the weapon system and out of range. That doesn't mean there aren't any safeguards against that either. Rather than solely using the laser weapon, the striker-mounted version of the weapon system is also equipped with two traditional kinetic weapons to take down targets. The first is a 30mm autocannon chain gun, manufactured by Northrop Grumman, which is compatible with pretty much any NATO-issued 30mm round. The autocannon is similar to that found on the famous Apache AH-64 helicopters, as the base design from the latter was used in its construction. The second is a 70mm rocket launcher from BAE Systems. The rocket delivery system is specifically designed to shoot down small, fast targets, like drones, with a laser-guided system for targeting and navigation. The missile rounds themselves use proximity-fused warheads, which don't need to cleanly hit a target to detonate but will explode whenever they reach within a certain distance of the target. Of course, the fallback plan for using either the autocannon or the missile launcher is just that, a fallback plan. While the auxiliary weapon systems have already been tested to be extremely effective at taking down mobile airborne targets, there's one problem with it. The rounds that these systems use are much more consumable than the electric power that the main laser does. Additionally, the autocannon relies on a continuous stream of fire to take down targets at range, with an estimate of roughly 1 in 30 rounds actually hitting the target. This means that the price-to-effect ratio for the auxiliary system is much worse than the laser's cost-effectiveness. As a result, a concentrated drone assault, one that overwhelms the laser's initial burst, would make the system not that much more effective than any other design currently in use. Considering the relative ease with which both Russia and Ukraine have been getting their drones in the air, this scenario might not be as fictional as it may seem, and there are a few other players that might be able to help take this to the next level. The first is Iran, a country that's been steadily building up its supplies of drones, as well as sending its long-range weapons to both Russia and its allies throughout the Middle East. The second is China. As the country with arguably the largest industrial potential due to its sheer population, China has been quickly catching up to the US in terms of economic and industrial output. Additionally, a large number of the commercial drones that Russia and Ukraine have modified for their use in the war come from China and are based on Chinese technology. Due to China and Russia being allies, it's also likely that the Chinese military has been learning all it can from Russia's successes and failures in Ukraine, particularly in terms of using drone warfare to its full potential. Considering China's capacity for producing drones, it's likely that the biggest test of the newly designed anti-drone systems will be a potential China-US war, rather than the current war in Ukraine. Regardless, the weapon system itself does have a few more kinks that need to be ironed out. The first is the laser strength. Currently, experiments performed during initial testing suggested that the Locust can take out a drone in roughly 15 seconds. While this might not seem like much time, a projectile moving 250 miles per hour can cover roughly a mile in that time. As such, if the target doesn't actually go down within those 15 seconds, there's a chance that the system doesn't actually work at all and will need to fall back onto the auxiliary defenses for full coverage. For commercial drones like the ones Russia and Ukraine are primarily using, this is not such a significant problem. A Mavic drone can typically travel at speeds in the range of 40 to 50 miles per hour, at least 5 times slower than the faster Grade 3 drones according to US classifications. In 15 seconds, these drones can cover a few hundred meters at best, which is more than likely going to keep them within range of the laser. Furthermore, the strength of the laser implies that smaller drones are more likely to be destroyed in less than 15 seconds. However, that still plays into the second potential issue: weather. The laser beam is made from a stream of photons that need to reach the system's target to heat it and destroy it. However, these photons can be absorbed or deflected by larger particles in the air, These include dust, moisture, rain, or fog, and when the photons get dispersed this way, a much lower concentration of the initial laser can reach the target, leading to much lower energy efficiency and destructive power. Of course, most other weapon systems are somewhat affected by adverse weather conditions. However, lasers are uniquely disadvantaged by the fact that weather can directly reduce the accuracy, efficiency, and damage potential of the weapon. The weather problem has been spotted in tests as far back as February 2024. In these tests, soldiers weren't impressed with the initial showing of the weapons, potentially due to performing them in adverse weather conditions. As such, it's possible that the anti-drone weapons system might not be as effective during the winter months, especially in temperate or colder climates that see more rain or snow. But there's yet another issue that could make the anti-drone system difficult to use to counter faster devices: limited range. As mentioned, the current iteration of the Locust has a range of only 2 miles for its targeting and locking system, while the theoretical range of the laser is much higher, as the photons travel in a straight line until they hit something. The effectiveness of the weapon is likely going to be significantly diminished at its maximum range and beyond. This makes the Locust potentially powerful when only defending a single, vital point. Of course, with some military targets being practically invaluable, creating a stronghold around a single building is more likely to be relevant for modern warfare. However, an extended front, such as the one between Russia and Ukraine in the war, would mean that the combatants would have to field a significant number of these weapon systems to reach anywhere near full coverage. This plays into the system's high starting cost. Even if the energy that powers the laser is dirt cheap, the actual weapon is still estimated to cost around $8 million. It's unlikely that those costs will dip significantly, making a single anti-drone defense system still a relatively costly purchase for most militaries. Then you have to consider that larger front lines would likely need a comparatively high number of these devices, and the price of setting up an effective drone defense can quickly add up. Despite those drawbacks, the Locust is perhaps one of the most promising defensive systems for the newly evolved drone warfare methodologies, and perhaps due to one key aspect: speed. The Locust is likely going to be faster than conventional defensive systems in a few ways. First, the test showed that the weapons need only about 15 minutes of deployment time. This is not a particularly important aspect, but it shows that a batch of these systems can be readily moved between one location and the next to provide more coverage and a rapid response system. Secondly, the speed at which the system can disintegrate small drones is likely going to be significantly shorter than 15 seconds for smaller drones like the Mavic. If the lasers are upgraded to be more energy efficient and powerful, it's highly likely that the drone might get dropped from the air in a matter of a few seconds given a solid hit on the wing. Third, and most importantly, the actual weapon, i.e. the energy transfer, moves at the speed of light, which is impossible to replicate with conventional weapons. This means that the operator has real-time feedback on whether they're hitting the intended target. Additionally, the targeting system doesn't need to account for travel time or the drone's trajectory when firing the laser. So long as the locking system has the drone in its sights, the laser is definitely going to be hitting it somewhere. Furthermore, since the Locust is already integrated with traditional anti-drone systems, including an autocannon and a missile launcher, it's practically equipped to deal with all manner of drones. As such, the effectiveness entirely depends on the logistics and the resourcefulness of the military that's operating it. One of the key factors that might mitigate this is energy production. However, given enough batteries or generators to power the system, it could have a much higher uptime than comparable anti-air defenses such as Patriot. The fact that the laser doesn't use tangible consumables is adding another point in its favor. After all, every time the laser shoots down a drone, the enemy has to make or deploy a new one, while the system is ready to go again in a matter of seconds. Plus, the tests being done with the Locust are currently limited to ground-only applications by mounting the system on a vehicle such as the Striker. However, it's been mentioned that the actual casing could fit on pretty much any type of vehicle. With high energy stockpile and auxiliary round demands, ships or even transport helicopters could prove to be the next perfect platforms for laser weaponry. An airborne anti-drone defense can literally take to the skies to shoot down enemy drones. However, there's even more potential in laser weapons than just shooting down drones. Laser systems have been in development for decades. The fact that they're capable of destroying drones now means that the US actually has a working prototype of a short-range laser weapon that can, in theory, melt through plastic. Given these conditions, it's not out of the realm of possibility that a larger and more powerful laser could be mounted on a ship or a vehicle and can be used to cleave through metal or make precision strikes against enemy control systems. As such, the Locust presents a possible breakthrough in military technology, as we might go from wars where soldiers fight one another to drones hunting vital targets to laser systems cleanly and efficiently cutting through equipment. While the US is among the leaders in developing such advanced laser technology, It's not the only nation to possess it. Israel unveiled its Iron Beam system as early as 2014, though it hasn't yet been deployed in active combat. Additionally, Turkey's Alka laser weapon is rumored to have been used successfully to shoot down a Chinese UAV in Libya. These advancements, alongside US innovations, naturally give pause to rivals like Russia and China. But what do you think? What does the future hold for laser weapons? Submarines are terrifying. They can travel through deep waters, undetected by ships on the surface, meaning they're ideal for subterfuge and launching unexpected attacks on opponents. More recently, they've taken on a nuclear slant, with countries like the US, Russia, and China designing subs that are capable of firing submarine-launched ballistic missiles, or SLBMs, carrying nuclear warheads. Yet, submarines are not without their disadvantages. But what if we told you that the US has been developing a submarine that eliminates almost all of them? A submarine that's so easy to build and deploy that the maintenance problem is mitigated massively. A vessel that is completely unmanned and entirely autonomous, meaning the human risk of operating submarines is taken out of the equation. And perhaps most importantly, a submarine that moves so quietly through the water that modern equipment isn't capable of tracking it. A submarine sounds like a sci-fi creation. It isn't. It's a reality, and it's named the Manta-Ray, the latest US military innovation that terrifies China and threatens to end Beijing's efforts to build its influence in the Indo-Pacific. So what is the Manta-Ray? In June 2021, the War Zone provided some details, starting with dubbing it a submarine that looks like a docked Star Wars ship. Using satellite imagery to back up its claims, it says the Manta-Ray is a submersible drone being developed as part of a Defense Advanced Research Projects Agency, or DARPA, project, with the submarine intended to be able to complete a host of naval missions. The submarine the War Zone examined is based in Naval Base Ventura County, a Californian base that focuses primarily on the research, development, and testing of new weaponry. It's estimated that the underwater drone's wingspan is around 45 feet, with its overall length being 33 feet. Again, the Star Wars reference comes into play, as the images we've seen so far make the submarine look more like a futuristic plane than a submersible vessel. This size places it somewhere in the middle of the spectrum of unmanned underwater vehicles, or UUVs, the US military has in development. The Manta-Ray is shorter than Boeing's Echo Voyager, for instance, which measures 51 feet long but is also much thinner. However, it's larger than the Remus 600, which is 10.6 feet long and barely over a foot in diameter. However, these dimensional specifications are estimates. Neither DARPA nor the Manta-Ray's manufacturers, Northrop Grumman, have released official figures for the submarine's size. That suggests that development is ongoing, meaning the estimates the War Zone reports may change once the submarine enters service. Speaking of Northrop Grumman, the company provides more details about what the Manta-Ray can do on its website. It describes the UUV as a new class of submersible, with its design being directly inspired by the winged fish that lends the sub its name. The Manta-Ray is designed to conduct long-range and long-duration missions, with a focus on ocean environments that humans are unable to explore in traditional submarines. Better yet, for the US Navy, the Manta-Ray is capable of conducting payload missions, meaning it can not only reach places that regular subs can't reach, but can also carry munitions, such as bombs and missiles, to attack targets. The Manta-Ray is also a modular vessel. At least that's the indication received from how Northrop Grumman shipped the submarine from its manufacturing site in Maryland to Naval Base Ventura County. Naval Technology reports that the UUV was shipped piecemeal, meaning it was broken down into sections that allowed it to be easily transported via road to its destination. Once it arrived, the Manta-Ray was quickly reassembled, ready for testing. A clear advantage over traditional submarines emerges. A regular sub can't be transported so easily. With the Manta-Ray, the US is getting a vessel that it could disassemble, transport to anywhere in the world via on-road vehicle, plane or ship, and then reassemble so it's ready to deploy. Furthermore, this piecemeal approach suggests that Northrop Grumman will be able to easily manufacture the vessel, as well as create replacement parts for existing Manta-Rays. Damage to one of a Manta-Ray's wings, for instance, may not mean the entire vessel has to go in for repairs. Instead, the broken wing can be switched for a new one, with the UUV getting back underwater again far faster than even a slightly damaged submarine will be able to do so. All very impressive so far. However, the two real difference makers for the Manta-Ray come from how it's powered and how it navigates. Starting with powering the vessel, DARPA's chief engineer for the Manta-Ray program, Brian Theobald, developed a novel idea. A 13-year veteran of Northrop Grumman's previous UUV projects, Theobald began working with a renewable energy technology company named ATTRIBUTIONS to come up with a way to harness and harvest the ocean's inherent energy to keep the Manta-Ray running. This partnership led to ATTRIBUTIONS creating a set of energy harvesting products that make use of an ocean's thermal gradient to generate the electricity needed to operate a vessel. This gradient is the difference in temperature between an ocean's surface and the waters below, with the surface waters typically being the warmer of the two. Thanks to Sea-Trek, the Manta-Ray is now equipped with technology that essentially allows it to keep itself charged with the electrical energy it needs to run without ever having to surface. In short, the Manta-Ray is capable of staying out at sea almost indefinitely, constantly delivering mission data as it does without needing to return to port. Instead, it can travel to various electricity storage locations to recharge. Plus, the fact that it doesn't need to resurface and can actually sink as low as the ocean bed makes it incredibly difficult for another country to track the UUV once it's at sea. Creating these capabilities didn't come without challenges. For one, Theobald's team needed to figure out a way to transfer the new energy its new system stored to the various rechargeable autonomous systems built into the Manta-Ray. That required a new invention, Niobicon. This self-insulating electrical connector tech is the brainchild of Jim Windgasson and Harvey Hack, who are both Northrop Grumman employees. Together they created a connector that's capable of being mated and demated even when exposed to water, eliminating the need for oils and rubber seals to prevent water from impacting an electrical connection. The connector's success all comes down to an element named niobium, which transforms into an ultra-thin and passive film the moment that it makes contact with water. As Windgasson explains, the film prevents current from leaking from the contact into the water. When the connector's two halves are mated, the insulating film is scraped off, allowing current to flow unimpeded through the connector. Once the current is no longer flowing, the film reforms upon contact with the water, and the Manta-Ray is recharged and ready to go. So how does the recharging station work? Dubbed the Mission Unlimited UUV station, the device is currently in its conceptual stage and is yet to be developed. But according to Theobald, it'll be deployable from a ship, after which it sinks to the bottom of the ocean and anchors itself. The station will then release a thermal energy harvesting pod, which is propelled up, generating and storing electricity thanks to the thermal gradient method mentioned earlier. After a few days, the pod will have gathered enough energy to fully recharge a Manta-Ray UUV, after which it heads back down to the charging station to be stored until the submarine needs it. Assuming the station is successfully developed, it's likely that the US will deploy dozens of them in the oceans around the world. In doing so, it'll create a network of charging stations that enable the Manta-Ray to stay underwater indefinitely. Better yet, the UUV will be taking advantage of an energy resource that's never going to run out. That's according to Kelly Rule, who is a mechanical engineer working with Sandia National Laboratories. Rule, who also serves as an advisor on the Manta-Ray project, says, "One of the things that's really interesting about ocean resources is that they're persistent. In other words, the waters never run out and the waves never stop." According to Rule, this persistence not only means the ocean itself is an unlimited energy resource for the Manta-Ray, but there is also potential for the production of power at a wider scale, especially if a device is developed to capture and transfer the power of ocean currents. Those are ideas for the future. For now, the US has a submarine in development that can theoretically operate underwater perpetually. Still, the energy issue wasn't the only challenge that Northrop Grumman's engineers faced. The communication of information was another. How do you transmit data from a vessel that's always underwater and has no humans on board to an appropriate source? Again, the insulated connectors built into the thermal energy pods the Manta-Ray will use to recharge itself come into play. Those connectors not only transfer electrical current, but can also be used to transfer data from the Manta-Ray to command bases on the shore. How? A clever technology that Northrop Grumman calls data bubbles. Theobald explained these devices. Data bubbles are tiny electronic devices that store data. When released from the station, they float to the surface and begin using their RF satellite communications antenna to transmit data to shore, to satellite, or to a ship. It's an ingenious solution to a communications problem inherent in having an almost permanently underwater vessel. The Manta-Ray itself never needs to surface, meaning it can't expose itself to enemy surface vessels to send data to its operators. Instead, the transmission of data is handled automatically whenever the UUV docks at a charging station, with the tiny data bubbles being capable of sending any information the UUV gathers with no chance of it being spotted by an enemy. How does this differ from the way traditional submarines communicate? Sandbox provides the answers. It points out that most above-surface military platforms, including ships, planes, and vehicles, communicate via radio. That's fine when you're above water. Radio waves can travel freely through the air. But a problem arises for submarines because radio waves get lost in conductive salt water, such as that which makes up the world's oceans. To compensate for this, American submarines currently use very low frequency, or VLF, transmissions to communicate information back to their bases. These transmissions rely on the creation of enormous antenna complexes, which the US has built in 5 places around the globe. Those installations are vulnerable. If the US found itself at war with a country that's capable of firing missiles at these antenna complexes, such as China, it could find itself quickly losing the ability to communicate with its submarines using VLW. It has contingencies in place for if that happens, claims Sandbox. For instance, the Take, Charge and Move Out, or Tacoma, aircraft are tasked with flying out to a submarine's location so they can deploy 5-mile-long antennas while flying in overlapping circles to receive messages. But that only creates more problems. Planes and antennas then become targets, in addition to giving away the general position of the submarine with which they're trying to communicate. The Manta-Ray's data bubbles solve these problems. While it's still possible that the Manta-Ray will also be equipped with VLW, why not build it in if you have the infrastructure in place to use it? It will no longer be reliant on the technology. An enemy could take out every VLW antenna station and fail to put a dent in the Manta-Ray's ability to transmit information to US command posts. Let's summarize what we know about the Manta-Ray so far. The UUV counteracts many of the disadvantages of modern submarines through the use of a host of systems and sensors that allow it to stay underwater for as long as needed. It can be transported in pieces and assembled at any suitable location, allowing it to be deployed from practically any American military base in the world. Considering the fact that the US has around 750 bases spread across 80 countries, it benefits from a multitude of deployment options that could theoretically allow it to send dozens, if not hundreds of Manta-Rays into the world's oceans. Once deployed, the UUVs can descend to depths no traditional submarine can reach, which is useful for both collecting data on the subs that it encounters, as well as for its novel method of recharging. Speaking of recharging, the innovative charging stations Northrop Grumman is developing not only allow that charging to happen while underwater, but serve as communication points thanks to their data bubbles. In short, the US is developing the next generation of undersea technology with the Manta-Ray. There are still challenges to confront before the UUV can be deployed. For one, much of the technology behind the charging stations is still theoretical, meaning it may take several months or years before it reaches a point where it can be reliably deployed. Northrop Grumman will also need to find a solution for the undersea corrosion issue. Constant exposure to salt water could wear away at the Manta-Ray to the point where it's forced to return to base early for repairs. There's also the pathfinding challenge, as the Manta-Ray is a UUV with no human on board to control its direction. It's likely that Northrop Grumman will implement artificial intelligence here, likely combined with an array of sensors that allow the Manta-Ray to identify its surroundings so it doesn't crash. These are all challenges that Northrop Grumman and DARPA will confront during the testing phase, a phase that is already well underway. In May 2024, DARPA announced that a Manta-Ray prototype had completed a full-scale in-water test around the Southern Californian coast. The tests, which took place between February and March, examined the craft's aerodynamic performance with a focus on submerged operations. Buoyancy, control, and propellers were all tested, allowing DARPA to confirm that the submarine could steer while propelling itself through the water. DARPA's Manta-Ray program manager, Dr. Kyle Werner, confirmed that the tests went well. Our successful full-scale Manta-Ray testing validates the vehicle's readiness to advance toward real-world operations after being rapidly assembled in the field from modular subsections, said Werner. In other words, the new UUV works, both in terms of its undersea operations and when it comes to being transported piecemeal to a location so it can be assembled and deployed. By now it's clear that the Manta-Ray is an extremely impressive piece of equipment and will only grow more impressive as DARPA and Northrop Grumman get their supporting systems up and running. But there's one country that will be watching these developments because it's terrified of what the emergence of the Manta-Ray could mean: China. As part of its massive military modernization, China has been building submarines at a rapid pace. That's according to a July 2024 Newsweek report, which claims that satellite imagery shows that China is building new diesel-fueled submarines to go along with 48 it already has. Of those 48, 21 are Type 039A/B submarines, also designated as the Yuan class by NATO, which weigh 3,600 tons and are capable of firing missiles at ships. Newsweek claims the Pentagon believes China has ramped up production of these Yuan-class subs to the point where it'll have 25 more of them by the end of 2025, bringing its total diesel-powered submarine stock to 73. That's on top of the 12 nuclear-powered submarines China currently operates. The message here is clear: China is trying to dominate under the waves. It's amassing a fleet of submarines that will give it a stronger presence than both Russia and the US, which currently have 65 and 64 submarines respectively. The problem for them is that the US is now playing chess while China is stuck playing checkers. As China invests more into building traditional submarines to expand its underwater reach, the US is investing in unmanned and revolutionary new submarines that represent the next generation of technological advancement with this type of equipment. As is so often the case, China is playing catch-up to the US. Once the Manta-Ray is ready to deploy, China will be at a clear disadvantage because it'll be restricted by the fact that its submarines are massive machines that require consistent maintenance and can only really move from place to place under their own steam. The US won't have those restrictions with the Manta-Ray. Remember, this is a small submarine that can be disassembled and transported to almost any location in the world. That means the US could pack it on a plane, if it wished, and fly it to a dock from which it could be reassembled and deployed. Why does this matter when it comes to China? Earlier we mentioned that the US has 750 military bases spread around the world. An enormous 120 of those bases are in Japan, with another 73 being in South Korea, both countries with which China is vying for control and influence over the Indo-Pacific. In particular, China is attempting to control the South China Sea, through which around a third of global shipping passes. China believes it owns almost the entirety of that waterway, which is a claim disputed by a host of countries, including the Philippines and Malaysia. The tussling over the South China Sea has led to China taking a submarine-heavy strategy in its waters. This was revealed back in 2016 by the BBC, which noted that China was building up a nuclear submarine force that would use the South China Sea as headquarters of sorts, from which China could break out into the Pacific Ocean as it saw fit. In particular, China has deployed Jin-class submarines into the South China Sea, with each being armed with up to 12 JL-2 nuclear missiles. The intention is clear. Those submarines patrol the depths of the South China Sea, lying in wait just in case they receive the order to attack another country, such as the United States. Key to that strategy's success is subterfuge. The subs need to be able to cross over the Pacific Ocean undetected so they can get within range of the United States. This is where the Manta-Ray presents a serious problem. Before the creation of America's new UUV, Chinese submarines essentially controlled the South China Sea, but more importantly, they were incredibly difficult to detect, leading to the US having no idea where they might be at any given moment. With Manta-Rays deployed from bases in South Korea and Japan, the US now has the ability to send an almost undetectable fleet of UUVs into the South China Sea to keep tabs on what China is doing. Those UUVs never need to surface, assuming the technology is developed to the point Northrop Grumman hopes, and can use charging stations on the ocean bed to send information back to US command. In short, China's traditional submarines won't be able to do a thing about the Manta-Rays gathering and transmitting information about them. Even if a Jin-class sub spots a Manta-Ray in South China Sea waters, the Manta-Ray can descend to depths the Jin-class can't reach. And worst of all for China, if war did break out, the fact that Manta-Rays can be equipped with a payload means the US could use them as kamikaze weapons to take out China's subs. After all, the UUVs are unmanned and, by all reports, appear to be easy to manufacture and assemble now the technological aspects have been confronted. Where does this leave China's submarine strategy? As recently as August 2023, China was running anti-submarine drills in the South China Sea, but those drills showcase how far behind the times China is when compared to the US. Reuters reports that the drills involved China sending out a dozen patrol craft, which were tasked with flying for 40 hours over the South China Sea to search for submarines that might be surfacing. Those planes also simulated attacks on the submarines they spotted. These drills will be useless for dealing with the Manta-Ray. A UUV that never needs to surface can't be spotted by patrol aircraft. Again, the chess versus checkers analogy comes into play. The US is developing a threat to China that upends every measure China has to guard against that threat. While Beijing is trying to figure out how to locate traditional submarines, it'll be completely in the dark when it comes to the ghost fleet of Manta-Rays that may be coming. Therein lies another problem for China. Detecting Manta-Rays will be almost impossible using current techniques. The maritime patrol aircraft strategy it was practicing back in August 2023 has existed since the First World War and has proven effective against traditional subs. The aircraft scans a large area of the sea, looking for surfacing subs or even their periscopes. Modern aircraft even have sensors that allow them to detect the heat from vessels that may be submarines. A diesel-powered sub, for instance, generates a distinctive heat signature that can be detected if it's near the surface. That signature doesn't exist in the Manta-Ray, thanks to it being electrically powered. The UUV also doesn't need to surface to use a periscope. There's nobody inside to examine the surroundings anyway, making patrol aircraft pointless in combating America's new submarine. The only thing they could possibly scan for are the thermal energy harvesting pods the charging stations release. Devices so small, they'll be almost impossible to spot. And even if the patrol aircraft spot a pod, they've only found the location of one of what could be dozens, even hundreds of charging stations under the sea. They haven't found a Manta-Ray. Beyond simply looking for periscopes and emerging submarines, patrol planes can also be equipped with magnetic anomaly detectors, or MADs. These magnets are placed in a pod at the rear of the aircraft to isolate the electromagnetic noise the aircraft itself generates. With that isolation complete, the MAD sensors scan the Earth's magnetic field to pick up on sound-based anomalies. This could reveal the presence of a submarine under the water, though only when combined with sonar buoys dropped by the aircraft, which are used to pick up sounds. That won't work against the Manta-Ray either, as the UUV barely generates sound, and certainly not to the level that a diesel-powered submarine would. Where does all of this leave China? It's facing the prospect of a United States that could, in a few years, deploy dozens of Manta-Ray UUVs into the waters it wants to control. These new submarines will be practically undetectable, allowing the US to gather data about Chinese operations and submarines, and could even be used to attack Chinese subs and ships thanks to their ability to carry a payload. Billions of dollars China has invested in traditional submarines could ultimately be rendered moot, as it once again finds itself playing catch-up to a technology that another nation has invented. Still, it's worth pointing out that the Manta-Ray and its many supporting systems are not operational yet, despite the submarine itself having undergone several successful tests. We'd love to hear what you think about this UUV and what it means for China. Could the US use the Manta-Ray to dominate the South China Sea and thwart Chinese plans?
The United States is developing a new air-to-ground missile, and it's designed just for China. Although the US military hasn't exactly said its new Stand-in Attack Weapon, or SEAR for short, is meant for China, they are one of the very few countries that pose the types of threats that the SEAR is designed to deal with. Today we're going to explore integrated air defense systems and the threats they pose to military aircraft. We will see why weapons such as the SEAR will give the United States the ability to strike deep into enemy territory and destroy even the most sophisticated air defense systems. We will learn how the SEAR will protect non-stealth aircraft and why it will allow the United States to dominate the skies in the event of a war with a major military power such as China. Let's start by talking about modern air defense systems and why they are so dangerous to American aircraft. The concept of an integrated air defense system was first devised in 1936 by British Air Marshal Hugh Dowding. During the First World War, Britain protected London from Zeppelin attacks by surrounding the city with 3 concentric rings. The outer ring consisted of searchlights and anti-aircraft artillery. The second ring was comprised of fighter aircraft. The innermost ring contained more searchlights and anti-aircraft weapons. Air Marshal Dowding changed all that. In his eyes, Britain would be best protected by establishing a single command center where information could be centralized and orders given out to multiple units to jointly protect a section of airspace. The best example of the Dowding system, as it later became known, is the Battle of Britain during the Second World War. In 1940, Germany was seeking to gain air superiority in preparation for a potential invasion of the British Isles. Over the course of the nearly 4-month campaign, Germany lost 1,900 aircraft before finally accepting the fact that it would never gain air superiority. Such losses were largely the result of the Dowding system. Information from observation posts and radar installations was collected in a filter room. That information was relayed to Fighter Command, who plotted the projected path of the incoming bombers and directed fighter aircraft to intercept them. That isn't very different from the integrated air defense systems today, at least in theory. An incoming threat is first detected by radar and other sensor equipment. The threat is then eliminated based on that information, often with anti-aircraft missiles. Speaking of anti-aircraft missiles, did you know that the first such system was developed in the early 1950s? The American MIM-3 Nike Ajax could intercept aircraft flying as high as 70,000 feet. It had a range of 30 miles and flew at twice the speed of sound. The Ajax carried 3 high-explosive warheads, one in the nose, one at the center of the missile, and one in the aft of the rocket. The warheads would detonate when the missile reached the predicted path of the aircraft. Over the years, integrated air defense systems have become more and more sophisticated. They are so effective that most aircraft cannot operate in contested airspace these days. 4th-generation aircraft such as the F-14, F-15, and F-16 must keep their distance out of fear of being shot down. The threat is so great that even some stealth aircraft may be at risk at closer ranges. Several countries have developed homegrown integrated air defense systems over the years, even those you might not suspect, including Iran. The operational range can vary. Israel's Iron Dome has a range of 43 miles, which might sound somewhat short, but it's quite sufficient for its needs. Other countries such as Russia and China have developed systems that can detect and intercept aircraft at very long distances. For example, the Russian S-400 Triumph integrated air defense system is said to be able to identify and track 36 targets at the same time at distances up to 249 miles. It can not only engage aircraft at such distances, but it can also take out precision-guided cruise missiles, such as the American Tomahawk, at a range of 25 miles. The S-400 is a great example of a modern integrated air defense system. It is comprised of a 55K6E command post, a 91B6E acquisition and battle management radar, a 92N6E fire control radar, and up to 12 separate launch vehicles that carry up to 4 missiles each. In other words, a networked S-400 system can fire up to 48 missiles at incoming threats. All of the components are mounted on wheeled vehicles, allowing them to be moved easily to other locations. Its impressive range will keep enemy aircraft far away, preventing them from carrying out missions. Not to be ignored, China's long-range HQ-9 is quite powerful as well. The HQ-9 has been described as a combination of the American Patriot system and the Russian S-300, the predecessor to the S-400. The system can detect incoming aircraft at a range of 125 miles and engage targets 77 miles away. The HQ-9 can be used against a variety of targets, including low-flying aircraft, helicopters, cruise missiles, air-to-ground missiles, and tactical ballistic missiles. It is a shoot-and-scoot platform, which gives it the ability to change its location quickly after firing upon a target. The number of components associated with a battery is up to debate, but includes a command vehicle, a control systems vehicle, a search radar, a target control system, and 6 launch vehicles, each with 4 missiles apiece. It's common for 4 batteries to work together, bringing the total number of missiles to 96. There have also been reports of a new variant of the HQ-9 that has a longer range and better sensor equipment, including a dual-mode, semi-active radar homing and scanning infrared seeker. It has a 180-kilogram warhead, with a proximity fuse, and can fly at speeds of up to Mach 4, making it incredibly hard to intercept. The HQ-9 is a potential nightmare for the US military. Even more so because of a chain of artificial islands China is building in the South China Sea. The Great Wall of Sand, as it's become known, is comprised of 7 artificial islands that were constructed by dredging vast amounts of sand and placing it on top of reefs above and below the water. They were then concreted to prevent erosion. Some of these artificial islands are more than 620 miles from mainland China and are being militarized. China has placed a wide range of offensive and defensive systems on these islands, including HQ-9s, anti-ship missiles, and laser and jamming equipment. There's even a 1.87-mile-long airstrip on Fiery Cross Reef that can be used by surveillance planes, fighter jets, and some bombers and cargo planes. These islands serve as an outer protective shield against attacks against the mainland, including ports that can be used for an invasion of Taiwan. They also pose a significant threat to the US Navy, whose ships will need to remain far out to sea until these defensive emplacements are destroyed. And that brings us back to why the US Air Force is developing the stand-in attack weapon. With SEAR, the United States will have a powerful weapon that can overcome even the most sophisticated air defense systems, leaving China susceptible to the full military might of the US Air Force and Navy. It doesn't matter that the HQ-9 can be relocated to a different position relatively quickly. The SEAR will still hunt it down and destroy it. Even if an operator shuts down system components to avoid detection, SEAR is going to find them and get them. That's not good news for China. SEAR is, as the name suggests, a stand-in weapon. That means it's designed to be launched within protected enemy airspace. With SEAR, American stealth aircraft can penetrate contested airspace and come within range of targets that need to be eliminated, and those targets do not need to be close by. SEAR is a long-range missile, and stealth aircraft add to that range. If SEAR can reach it, it can destroy it. Design and deployment of the SEAR will take less time than most new weapon systems. That's because its basic structure is modeled on a new missile being designed for the US Navy, the Advanced Anti-Radiation Guided Missile Extended Range, or AARGM-ER for short. If you aren't familiar with the Extended Range AARGM, you should be. It's quite a powerful weapon itself. The AARGM-ER is a long-range air-to-ground radar hunting missile developed by the US Navy for its FA-18 Super Hornet, EA-18 Growler, and carrier-based stealth F-35C aircraft. It can also be used by the Air Force's fleet of F-35As. The concept of the AARGM-ER is simple. It's meant to take out enemy air detection systems by homing in on enemy electronic transmissions produced by radars, jamming devices, and radio signals. Once a target is identified, the missile adjusts its trajectory and destroys it with devastating effect. It's primarily meant to be used against ground targets, but can also hit moving vehicles and ships. Designed by a subsidiary of Northrop Grumman, Alliant Tech Systems, the development of the AARGM-ER began in 2016. Testing began in 2021 and concluded in 2023. Deliveries are scheduled to begin in early 2024, with the missile becoming fully operational shortly thereafter. So far, the US military has ordered 118 missiles. Other countries, such as Australia, have also placed orders. Australia has ordered 63 missiles and Finland is interested in acquiring 150. The Netherlands has confirmed that it too will purchase the missile for its F-35s. The missile is about 13 feet long, weighs 467 kilograms, about 1,000 pounds. It includes a multi-sensor guidance system with a passive digital guidance head, active millimeter radar, and a GPS and inertial navigation system. It uses a smokeless solid propellant and can fly at Mach 2. The ARGM-ER uses a passive anti-radiation homing receiver, a millimeter wave radar, a GPS, and an inertial navigation system to identify a target and guide the missile to the target. The warhead uses Northrop Grumman's Lethality Enhanced Ordnance, or LEO, fragmentation technology, which reduces collateral damage while still packing a wallop. Why are we talking about the ARGM-ER? Because it's very relevant to the development of the SEOR. The US Air Force had been following what the Navy was up to with the ARGM for a while, and it liked what it saw. So much so that it started thinking about building a missile of its own that could take out a wide range of targets that wouldn't break the bank and could be developed quickly. Thus, the idea of the SEOR was born. The missile would be designed for the F-35A and carried within its weapons bay, so it doesn't interfere with the aircraft's stealth profile. Although the Air Force recognized that SEOR could potentially be used by other stealth aircraft, such as the upcoming B-21 strategic bomber, it is a weapon for the F-35 first and foremost. And it isn't meant to be a missile designed just to destroy air defense systems. While SEOR will be able to do that, and do it well, the Air Force wanted the missile to do more. It wanted a weapon that could take out a wide range of different targets. So when the Air Force submitted a budgetary request in 2018 to study its options, it laid out all of the things it wanted SEOR to do. It wanted an anti-access area denial weapon, or A2AD, that could be used against fixed and rapidly relocatable targets. In its budgetary request, the Air Force specifically mentioned integrated air defense systems, theater ballistic missile launchers, land attack and anti-ship cruise missile launchers, GPS jammers, and anti-satellite systems. It will also be able to sink moving ships as well as fixed assets such as command and control centers. In other words, the Air Force wanted a highly maneuverable air-to-ground missile that could target pretty much everything, even if it was moving. And it wanted the development to heavily leverage the design and technology being incorporated into ARGM-ER so that it could be developed and tested more quickly and at a lower cost. In 2020, the Air Force issued an RFI, Request for Information, to Northrop Grumman, L3Harris, and Lockheed Martin to establish an integrated digital environment to design, develop, and test the initial increment of the SEOR system, and it wanted it to be done using digital engineering methodology. What is digital engineering? Digital engineering is a way to design things using computer simulations, modeling, advanced algorithms, and even artificial intelligence. With digital engineering, almost all aspects of a project can be built, reviewed, and tested without a physical prototype. It can be used to develop a wide variety of systems such as circuit cards, aircraft, and even intercontinental ballistic missiles. In recent years, the US Air Force has been very focused on digital engineering because it speeds up projects and allows for multiple partners to build components based on an initial design. It's for that reason that digital engineering was included in the RFI requirements. The advantages that Northrop Grumman had, such as its strength in digital engineering and the fact that it designed the ARGM-ER missile that SEOR was to leverage, ultimately led Lockheed Martin and L3Harris to bow out of the competition. So in September 2023, the Air Force awarded a $700 million contract to Northrop Grumman to move forward with the project. Since SEOR is still being designed, there aren't many specific details regarding the missile. But based on what we do know, it looks like SEOR will be a game changer if war ever broke out between the United States and China. SEOR will be a modular platform, meaning that it will be possible to swap out components relatively quickly. It's not clear if the ability to change components will be used to tailor the missile for specific missions or simply make it easier to upgrade. Conceivably, it will do both. It will also feature open architecture interfaces to allow for subsystem upgrades to keep up with electronic improvements to the F-35 over time. SEOR will be a supersonic missile capable of speeds of at least Mach 2. It will be highly maneuverable, able to change course as needed with or without being controlled by the pilot. It will have hardened, low-signature sensors, making it difficult to identify and intercept. SEAL will not be limited to seeking targets directly ahead of it. It will also be able to look for targets from either side and potentially behind it. Such technology already exists and is being used on the AIM-9X Sidewinder. It will also use a new warhead being developed at the start of the project. Since SEAL is meant to be used against many different targets, a fragmentation-based warhead, such as found on the Argom-ER, may not be effective enough against all of the targets that SEAL is designed to destroy. One of the most interesting aspects of the SEAL is that it can be launched without a specific target in mind. Essentially, an F-35 pilot will be able to select a geographic area and allow the missile to pick out its target as it closes in. SEAL will also have a two-way data link that could provide the pilot with the option to select a new target area while the missile is in flight. It's even conceivable that with this data link, it can communicate with other missiles in flight and share targeting information. That will be exceptionally helpful in directing standoff missiles that are fired outside of the range of air defense systems. SEAL is the right missile at the right time. Tensions are increasing between the United States and China at an alarming rate. Some of the tension is centered around the artificial islands that China has built. China is declaring water and airspaces right around these islands, which the United States considers open waters. This has led to several incidents between the militaries of both nations, and neither side is backing down. But that's not all. The most likely scenario that would lead to a major conflict between the two powers is a Chinese invasion of Taiwan. Taiwan is an interesting story unto itself. It's part rogue province and part autonomous state. Although most of the global community does not consider Taiwan a country, most major powers maintain unofficial diplomatic and military relations with its government. Even Taiwan is a bit confused as to what it is. None of that matters because mainland China considers Taiwan as part of the People's Republic of China, and it wants it under its complete control. The level of Chinese saber-rattling is intensifying. China even released a documentary in 2023 about its state of readiness to invade Taiwan. In the event of such an invasion, would the United States defend Taiwan? Well, that's a good question. Officially, the United States has been very ambiguous as to what it would do if China attempted to invade Taiwan. Unofficially, it certainly would. We know that because US President Joe Biden has made direct statements that the United States would protect Taiwan. He hasn't been ambiguous about that at all. In a television interview in 2022, Biden was asked if the United States would defend Taiwan. His answer was yes. In any direct conflict with China, the United States need to gain air superiority early on, and that's a problem. As we've seen, the range and sophistication of China's defense network will make it extremely dangerous for American aircraft and naval vessels to operate anywhere close to Taiwan. That's where the SEAL comes in. Because the stealth F-35 can penetrate enemy airspace, SEALs can clear a safe path for non-stealth strike aircraft to carry out their missions. Not only that, SEAL can take out a wide variety of other targets, including anti-ship launchers, that will initially keep the US Navy out of the fight for Taiwan. An actual war between the United States and China is highly unlikely anytime soon. But if such a war does break out in the future, the US Air Force will be ready and able to deal a serious blow with SEAL. What do you think? Can the United States protect Taiwan from a Chinese invasion? How much of an impact will SEAL make in the event of a war between the United States and China?
The Dark Eagle can fly. Those words are music to the ears of anyone who's watched China boast about dominating the hypersonic race. For years, Beijing's relentless investments and rapid advancements left the US playing catch-up. The US officials even openly admitted it, claiming that China's systems and infrastructure outpace everyone, including Russia. But that era is over. After years of watching Beijing claim the lead, the US has answered with something that does more than just compete, it obliterates everything and everyone in its path. The Dark Eagle isn't just a missile, it's proof that when America shows up, it shows up swinging. Here's everything you need to know about this impressive weapon that China is entirely defenseless against. Officially known as the Long-Range Hypersonic Weapon, LRHW, the Dark Eagle is a surface-to-surface missile system built for speed, precision, and power. This land-based, truck-launched hypersonic marvel is engineered to deliver devastating strikes at intermediate ranges, giving the US a clear edge in modern warfare. This much-needed edge is the result of a powerful collaboration between the US Army and Navy. Each of these branches contributed its unique expertise to create this game-changing weapon. The Navy might refer to it under a different name, the Conventional Prompt Strike System, but the essence of the missile remains the same. This missile is also making a name for itself as the missile to beat. The partnership between the Army and Navy began in 2018 when the latter was tasked with leading the design of the Common Hypersonic Glide Body, with significant input from the former's Rapid Capabilities and Critical Technologies Office. This joint effort has been crucial in advancing hypersonic technology. Vice Admiral Johnny Wolf Jr. of the Navy's Strategic Systems Program couldn't have put it better, calling the collaboration a demonstration of how both branches can come together to develop a transformational weapon system. The result of this collaboration? A missile designed for both land and sea platforms. While the Army prepares to deploy the Dark Eagle, the Navy is integrating its own version into surface and subsurface platforms, ensuring the US military's reach will be felt far and wide. So what did the brilliant minds from these two branches come up with? A design that's testament to cutting-edge engineering, of course. The Dark Eagle combines the best of both advanced propulsion and hypersonic glide technology. At its core, the missile consists of a large rocket booster that carries the unpowered Common Hypersonic Glide Body, CHGB, in its nose cone. Once the booster propels the missile to incredible speeds and altitudes, it releases the CHGB, which then glides towards its target at hypersonic speeds, leaving anything in its path vulnerable to its kinetic energy warhead. This design draws on decades of innovation. The CHGB is actually based on earlier projects like the Army's Alternate Re-Entry System, which was tested in early 2010. This technology in turn traces its roots to the Sandia Winged Energetic Re-Entry Vehicle Experiment, SWERV, from the 1980s. With Dynetics responsible for building the glide vehicle and Lockheed Martin tasked with constructing the booster and handling missile assembly, the Dark Eagle represents the culmination of years of research and collaboration from some of the most trusted names in defense technology. And that's what makes it truly special and stand out in the hypersonic world. The US's goal wasn't to put out one hypersonic weapon after another in some desperate scramble. Rather than rushing and flooding the market with unreliable and incomplete systems, the US took its time to create the Dark Eagle, and its specifications show this. The Dark Eagle's boost glide technology allows it to reach unimaginable speeds. The speed in question is up to Mach 17. That's 17 times the speed of sound, or 12,940 miles per hour. At this speed, the Dark Eagle doesn't just break the sound barrier, it shatters it, leaving any attempt at defense in the dust, right where any Chinese assets targeted by this missile will find themselves. But the speed isn't the only impressive thing about the Dark Eagle. With an operational range of over 1,724 miles, the Dark Eagle has the longest reach of any land-based strike system in the US inventory. This range means that the Dark Eagle can strike high-value, time-critical targets from a distance with unparalleled precision. Whether it's a heavily fortified military installation or a critical command center, the Dark Eagle's warhead will deliver a devastating blow exactly where it's needed. What truly sets the Dark Eagle apart, however, is its maneuverability and survivability. Its hypersonic glide body can evade even the most advanced air defenses, ensuring it can reach its targets in the most contested environments. This includes even anti-access area denial A2AD zones, where traditional strike capabilities are often rendered useless. The fact that the Dark Eagle can penetrate A2AD zones is of immense importance, given that China continues to enhance its anti-access area denial capabilities. So far, these capabilities have dramatically altered the balance of power in the Indo-Pacific. Thanks to a web of advanced anti-ship ballistic missiles, anti-ship cruise missiles, surface-to-air missiles, and a robust fleet of submarines and fighter jets, China has designed a mighty defense network intended to keep foreign military forces at bay, especially the US. And that's the primary goal of China's A2AD systems, to prevent or at least complicate any foreign intervention in key regions like the Taiwan Strait, by denying adversaries the ability to operate freely in these contested zones. But there's no denying it when it comes to the Dark Eagle. Its speed and maneuverability allow it to outpace and evade the sophisticated missile defense systems embedded within China's A2AD strategy, such as the S-400 missile system or the DF-21D anti-ship ballistic missile. And that was precisely the goal of the Dark Eagle, to ensure no one can stop the US. With China racing to field hypersonic weapons, the US recognized the need to stay ahead in this rapidly evolving arms race, a very dangerous race at that. For the US, the development of the Dark Eagle and other hypersonic weapons became a matter of national security and strategic advantage. That's why the entire country rejoiced once it was announced the Dark Eagle completed a successful end-to-end flight test on December 12, 2024. This monumental test demonstrated the missile's extraordinary capabilities, not just in terms of its raw speed, but also its precision, maneuverability, and ability to navigate hostile environments. The test was the culmination of years of rigorous research and development, and it marked a major step towards securing a technological advantage for the US military in an increasingly contested global landscape. But before exploring this test in more detail, it's important to note that it was just the latest in a series of increasingly successful milestones, each one propelling the missile closer to operational status. The journey began in October 2017, when the first test of the Dark Eagle took place. The missile, designed to fit the launch tube of an Ohio-class ballistic missile submarine, was fired from Hawaii and flew over 2,000 nautical miles to the Marshall Islands at hypersonic speeds. The initial flight was a significant proof of concept, demonstrating that a missile could travel at extreme speeds while maintaining accuracy over such a vast distance. The results were promising, and the development team knew they were on the right track. But they also knew that much more testing would be needed to fine-tune the technology. Fast forward to March 2020, when the CHGB, a key component of the Dark Eagle system, underwent another round of testing. During this period, subsystems of the LRHW system were tested as part of Project Convergence 2022, a critical testing program aimed at advancing the Army's capabilities. These tests focused on refining the missile's components and ensuring they could work in unison, setting the stage for future end-to-end tests. This phase was crucial for demonstrating how the missile would perform in real-world operational conditions. Then came June 28, 2024, another pivotal moment in the Dark Eagle's development. On this day, the US Department of Defense announced the successful completion of an end-to-end test of the US Army's LRHW All-Up Round or AUR missile and the US Navy's Conventional Prompt Strike missile. Launched from the Pacific Missile Range Facility in Kauai, Hawaii, the missile hit its target over 2,000 miles away in the Marshall Islands. This successful flight was a clear demonstration of the missile's capability to operate at hypersonic speeds over great distances and confirmed that the technology was maturing rapidly. With this test, the system was beginning to prove its worth not just on paper, but in practice. But it was the second successful flight in December 2024 that really grabbed everyone's attention. This test, conducted at Cape Canaveral Space Force Station in Florida, was monumental for several reasons. First, it marked the first live-fire event of the missile using a ground-based launcher and a battery operations center, a key step in demonstrating the Dark Eagle's operational readiness. The missile then flew at hypersonic speeds, more than 5 times the speed of sound, and successfully struck a target over long distances. As a result, this test proved that the entire missile system was functioning as intended, not just individual components. The Pentagon quickly hailed the test as a major milestone, signaling that the weapon was getting closer to being combat-ready. Secretary of the Army Christine Wormuth celebrated the achievement, saying, "This test builds on several flight tests and demonstrates that we can put this capability in the hands of the warfighter." She emphasized that the successful flight showed the missile's potential to be integrated into the Army's arsenal. Secretary of the Navy Carlos del Toro also voiced strong support, highlighting that the test was a crucial step toward integrating the hypersonic missile into both Navy surface and subsurface ships. But while this test was a significant leap forward, it's not the end of the road. The US military is already looking ahead to the next phases of development. The Pentagon is gearing up for what's known as Hypersonics 2.0 and 3.0, an ambitious plan to refine and expand the capabilities of hypersonic weapons. These phases will focus not just on the weapons themselves, but also how they will integrate into the broader military strategy. This particularly applies to how these weapons fit into what's referred to as a kill web. The kill web is a multi-layered approach to warfare, where various assets from land, sea, air, space, and cyberspace work together to create an interconnected system of attack. As Vice Chairman of the Joint Chiefs of Staff Admiral Christopher Grady notes, hypersonic weapons will not only help the US strike adversary targets, but also defend against hypersonic weapons from other nations. This dual capability is critical as China continues to push forward with its own hypersonic missile program. In terms of specific milestones, the first LRHW battery, which includes 8 missiles, was deployed in 2023. This deployment is a critical step toward full operational capability for the US Army, with an expected timeline of 1 to 2 years for achieving full readiness. Once operational, the LRHW will be positioned in Germany to counter advanced threats, including Russia's Oreshnik hypersonic complex, as tensions in Europe remain high. The Navy, too, is preparing to integrate hypersonic capabilities into its fleet. The Navy plans to deploy the missiles on its Zumwalt-class destroyers by 2025. This move will greatly enhance the service's ability to strike targets at long range in an increasingly competitive global landscape. The Navy also intends to deploy the weapon aboard the Block 5 Virginia-class submarines by 2029, providing a stealthy, undersea launch option for hypersonic weapons. This means that China and other US adversaries won't be safe anywhere, not in the air, not on the ground, not in the sea. Of course, China won't just sit idly by. The country has already been advancing its missile defense and air defense capabilities rapidly. The Dark Eagle's debut will only push China to escalate its efforts further. With this in mind, let's see what the Dark Eagle is currently up against. China has spent years developing a range of technologies aimed at enhancing its ability to defend against missiles, particularly in the face of perceived threats from the US, Russia, and increasingly India. Beijing has several defense systems in place or under development, including ground-based mid-course interceptors like the Dongning-3 (DN3) and the HQ-19, which are designed to intercept ballistic missiles during their mid-course and terminal stages. The DN3, a hit-to-kill interceptor, and the HQ-19, derived from the HQ-9, are often compared to US systems like the Standard Missile-3 and THAAD. China's development of ballistic missile defense (BMD) has been strongly influenced by its desire to protect its political leadership, nuclear forces, and key infrastructure from preemptive attacks. The country has made significant progress in developing ASAT, anti-satellite weapons, which share technologies with BMD systems. Both of these systems are part of a multi-layered defense strategy aimed at countering incoming ballistic missiles, but they would struggle to handle hypersonic threats like the Dark Eagle. The Dark Eagle operates at speeds far beyond the capabilities of China's missile defense technologies. But more importantly, this missile can perform unpredictable maneuvers mid-flight, making it incredibly difficult to track and intercept with traditional ballistic missile defenses and air defense systems. China's current defense systems can't tackle a missile that follows an unpredictable trajectory. They might be capable against slower, more predictable threats. However, they simply don't have the speed, agility, or precision needed to effectively target and intercept a hypersonic missile. But what about China's air defense systems? On the air defense side, China has also invested heavily in advanced systems such as the HQ-9 and the S-400 to defend against a wide variety of threats. This includes missiles, aircraft, and drones. The HQ-9, deployed in contested regions like the South China Sea, and the S-400, a Russian system, have the capability to intercept shorter-range ballistic missiles as well as cruise missiles. However, these systems are primarily designed to counter traditional air and missile threats, not high-speed, maneuvering hypersonic missiles like the Dark Eagle. China's lack of a robust early warning sensor network is another significant gap in its air defense architecture. While the country has made strides in developing satellites for missile detection, it still lags behind the US in terms of sensor technology. The radar and satellite infrastructure needed to detect and track hypersonic missiles in real time is still in its infancy. This places China at a significant disadvantage when it comes to defending against advanced threats like the Dark Eagle. Still, China is moving forward with the development of systems like the HQ-26, a naval missile defense interceptor. It's also exploring ways to integrate more advanced sensors and radars into its existing systems. However, much of this technology is still in the testing and development phase, and its effectiveness against hypersonic threats has yet to be proven. In other words, none of China's existing defense systems are well suited to handle the unique characteristics the Dark Eagle brings to the table. The speed, maneuverability, and unpredictability of this system places it well beyond the capabilities of China's entire missile defense infrastructure. As a result, if the US were to use the Dark Eagle against China, there would be little to no chance of interception or effective countermeasures. The Dark Eagle would strike any target within minutes, rendering China's defense systems obsolete before they even had a chance to react. And these targets, whether military aircraft, radar systems, or key infrastructure, would be reduced to dust almost instantaneously. But that's just how the Dark Eagle will perform against China. What about other nations with hypersonic capabilities? As you can probably guess from all the mentions in this video, Russia is another major contender in the hypersonic race. Around the time the Dark Eagle was successfully tested for the second time in 2024, Russia's President Vladimir Putin went on an entire campaign to showcase Russia's own hypersonic missile, the Airstrike. Now it's hard to miss Putin's confidence in this missile, as he's practically shouting from the rooftops about how amazing it is. According to him, this missile, which strikes at speeds of Mach 10, can render any countermeasures completely useless. Putin even had the audacity to suggest that the Airstrike could make nuclear weapons obsolete, boasting that it's basically untouchable by modern air defenses. However, while the Airstrike reportedly boasts impressive speed and power, it doesn't quite match the Dark Eagle in terms of versatility. Though it's still unclear whether the Dark Eagle is nuclear capable like the Airstrike, this doesn't make it any less lethal. Its focus on sheer precision and speed makes it a devastating weapon on its own, even if it does have a non-nuclear status. Plus, the US has a clear edge when it comes to integrating these weapons into a full-spectrum military strategy, allowing the Dark Eagle to leave the Airstrike in the dust too. When it comes to missile defenses, Russia fields two notable systems, the S-400 and the S-500. We've already discussed the incompetence of the S-400 to counter the Dark Eagle, but what about its more advanced counterpart? Well, on paper, the S-500 is capable of intercepting hypersonic weapons, but let's be real, Russian systems always look great on paper, but when it comes to the actual test of battle, they fall short. The truth is that in practice, the S-500 is still unproven. Perhaps it could be adapted to intercept hypersonic missiles, but tackling such a sophisticated high-speed weapon like the Dark Eagle is a whole other beast. In contrast, the US is far more advanced in hypersonic defense and missile defense overall. The ground-based mid-course defense GMD system, Aegis BMD, and a more mature space-based tracking infrastructure place the US ahead of China and Russia in terms of missile defense coverage as well. The US also maintains sea-based missile defense systems that enhance its ability to track and intercept threats. More importantly, there are ongoing efforts to build defenses against weapons that travel at speeds surpassing Mach 5. In other words, the US isn't just looking to maintain its lead, it's actively working on expanding its edge, both in offense and defense. But where do you see this hypersonic race heading next? Will China or Russia be able to develop effective defenses against the Dark Eagle, or are we witnessing the dawn of a new era where the US military once again holds the upper hand? If a military clash erupts in the Indo-Pacific, the US Navy's top question will be, how do you sink a Chinese aircraft carrier fast? The answer might just be more surprising and terrifying than anyone expected. At this year's RIMPAC exercise, the US Air Force unveiled a game-changing capability that left China's military brass sweating. A cheap, devastating weapon dropped from the most advanced bomber ever built. A massive 39,000-ton ship was sent to the bottom of the ocean in minutes, thanks to a bomb so smart it doesn't even need human guidance. This is QuickSync, and it's set to rewrite the rules of naval warfare. But how did the US develop this stealthy ship killer? And why does it strike fear into the hearts of China's naval commanders? Stay tuned as we dive into the cutting-edge tech and tactics that could change the future of the Indo-Pacific. As tensions in the Indo-Pacific rise, the stakes are higher than ever. The question of how to neutralize a powerful enemy carrier is more crucial now than at any point since World War II. Even during the Cold War, the United States and its allies understood that any conventional confrontation with the Soviet Union would be decided on the battlefields of Europe and in the skies over them. In contrast, any conventional confrontation with China will be decided in the seas and skies of the first island chain. China understands this too, which is why it shifted much of its military resources away from its tradition of being a strong land power and into a bid to become a sea power. For a China that depends on maritime trade coming through the hostile choke points of the first island chain, there is no other option. As a result, China expanded its navy. It now has 3 aircraft carriers with a 4th on the way, aiming to increase its fleet to 5 carriers by 2030 and 6 by 2035. Each carrier has shown advancements like the Fujian's catapult propulsion system. However, these developments are not without challenges. China's rapid expansion lacks the battle-tested experience and logistical support that the US Navy has honed over decades. While the Type 004, China's first nuclear-powered vessel, promises longer missions, it still faces significant hurdles in matching the operational capabilities and global reach of the US carrier strike groups. The United States Navy has 11 aircraft carriers in service, but it cannot commit all of these to the Indo-Pacific region. Other hotspots like the Middle East and Eastern Europe also require America's attention. This reality is one of the things Beijing is counting on. China hopes that in the 2030s it will achieve local naval superiority against the divided US Navy. But dreaming and doing are 2 very different things, especially when you're up against the world's most battle-hardened and technologically advanced fleet. America's military brass understands this threat, and so is looking to find force multipliers, ways to inflict disproportionate harm to an adversarial China with fewer resources, and we saw a couple of these flowers begin to bloom in the summer. RIMPAC, Rim of Pacific, is the world's largest naval military exercise. It occurs every 2 years, usually in June or July. The 2024 exercise involved participants from 29 countries. This year's RIMPAC was notable in more ways than one. The United States used it to reveal the AIM-174B, its air-launched version of the RIM-174. The incorporation of this ship-based missile onto an air platform now gives the United States comparable reach to China's PL-15 and PL-21 missiles. However, these missiles are versatile and can hit targets in the skies, on land, and on sea. Thanks to their air-launched attributes, these missiles can potentially threaten important Chinese military assets in its home territory, key Chinese ships, and make any invasion of Taiwan even more difficult and costly. In most years, the revelation of these missiles, once thought to be exclusive to ships, may have been the most notable talking point from RIMPAC. But the US military has another trick up its sleeve, one even bigger than the last. The Air Force was not about to let the Navy steal the spotlight.
One of the stars of the Air Force's show was the USS Tarawa, on loan from the Navy. This ship was 820 feet in length and weighed 38,900 tons. The Tarawa was built in the early 1970s and decommissioned in 2009. Named after the Battle of Tarawa in World War II, it was an amphibious assault ship. The US Navy gives the following mission description to amphibious assault ships. They must be able to sail in harm's way and provide a rapid buildup of combat power ashore in the face of opposition. This means amphibious assault ships have to carry a lot of stuff, including aircraft. These ships can do vertical short takeoff and landing (VSTOL), short takeoff vertical landing (STOVL), vertical takeoff and landing (VTOL), tilt rotor and rotary wing (RW) aircraft operations. In addition to helicopters, these ships are capable of hosting F-35B aircraft, which are designed for short takeoff and vertical landing. Unsurprisingly, the US Navy's official fact file on amphibious assault ships said that they resemble small aircraft carriers. The Tarawa was in fact only slightly smaller than France's Charles de Gaulle aircraft carrier. So if you need to practice operations against an aircraft carrier, a decommissioned amphibious assault ship like the Tarawa is a pretty good bet, which is why we've referred to this ship in the past tense, because it is no more. It lies as a wreck beneath the waves. The once gallant ship became a giant floating punching bag for the US and its allies participating in RIMPAC, but punching bags are useful for training in preparation for a fight, and the Tarawa was no exception. The Tarawa was hit with several weapons. One of these included an AGM-158C LRASM launched by an FA-18 Super Hornet. This weapon is a stealthy subsonic cruise missile with a range of over 200 miles and packs a 1,000-pound warhead. The missile is also a smart weapon, able to navigate autonomously in response to enemy radar and defenses through artificial intelligence that does not require human or even satellite guidance. The missile hit and did heavy damage, but it was not enough to sink the ship. After the LRASM impact, an Australian destroyer, the HMAS Sydney, got in on the fun. The Sydney used a naval strike missile. This is a projectile developed by the Norwegian Kongsberg Defence and Aerospace Company, the same firm behind the NASAMS missile defense system. It has a range of at least 115 miles and carries an 880-pound high-explosive warhead. The test was an important one for the Australian Navy. Vice Admiral Mark Hammond, the Australian Chief of Navy, hailed it as a demonstration of his country's ability to hold a potential adversary at a long range and deter any hostile projection of power against Australia. Everybody understood who that was referring to. The missile hit the Tarawa and did more damage, but the large ship stayed afloat after this impact also. But these two were just the opening acts for the main event. A B-2 Spirit, armed with a bomb called the Quicksink, now flew into action. The Air Force started the Quicksink program in 2021, when it toyed with the concept of using standard JDAM bombs to hit a specific point on an enemy ship, including at the top, the waterline, or just below the waterline. The Air Force wanted to develop this Quicksink capability out of recognition of this new threat environment that the United States and its allies faced. With the increasing Chinese naval threat in the First Island chain, it realized that it needed to get much more involved in the anti-ship business than it had been in the past. The Quicksink program was designed to allow the Air Force to modify not only existing weapons for anti-ship purposes, but future weapons as well. One modification to the typical JDAM was a redesigned nose plug. The new plug prevents a JDAM bomb from bouncing in an unexpected direction if it hits the water. The concept was first put to the test in 2022. This test involved the use of a GPS-guided GBU-31 bomb launched from an F-15E Strike Eagle to hit a cargo vessel. The bomb penetrated the target and split it in two, causing it to sink rapidly. Air Force officials have been high on the Quicksink, saying that it's a more effective way to sink ships than heavy torpedoes. Being air-launched, the Quicksink provides more flexibility than a torpedo, potentially at a longer range. The RIMPAC test involved a Quicksink kit attached to a 2,000-pound Mark 84 bomb. The kit includes GPS-guided tail fins, which steer the munition to its target once dropped from the air. Quicksink kits also involve new radar seekers installed on the nose of the munition to help it identify and move toward the target. The Quicksink kit also comes with an infrared imaging seeker mounted to the side of the bomb. This seeker helps the bomb to identify its target ship and guides the bomb towards the target's vulnerable hull just below the waterline. The bomb detonates there, producing a similar effect to a heavy torpedo launched from a submarine. This was the Tarawa's fate in the RIMPAC exercise. The B-2 Spirit took off with the converted Mark 84 and sunk the Tarawa in this one shot. The message was clear. The United States had demonstrated its ability to sink very large ships very quickly through the platform of a bomber that would be difficult to detect beforehand. There are only 19 B-2 bombers in the USAF's fleet, but the B-21 Raider will have the same capability once it makes its debut in the 2030s, and there will be a lot of them. The Air Force has suggested that a fleet of around 200 B-21s will be needed to deter and defeat any foe. A force of hundreds of B-21s armed with quick-sink bombs poses a significant danger to China's naval plans. Another attractive part of the quick-sink munition is in how low the cost is. The B-2 Spirit might be the most expensive aircraft ever to take to the sky, but the mission it carried out at Rimpak can be done on the cheap. Anti-ship missiles are very expensive. For example, a single LRASM currently costs $3.24 million. The Naval Strike Missile that also hit the Tarawa had a unit cost of nearly $2.2 million in 2021. Other anti-ship missiles like the Block 2 Harpoon can cost over $2.25 million per unit. The RIM-174, now also the AIM-174B in its air-launched configuration, can cost nearly $5 million apiece. Torpedoes are also expensive. The most powerful weapon to sink large nuclear submarines and surface ships in the US military's arsenal has been the Mark 48 torpedo. This torpedo is designed to detonate underneath surface ships and break apart their hulls, causing them to take in water fast, much like the quick-sink. However, these torpedoes are even more expensive than anti-ship missiles. The latest version of the Mark 48, called the Mod 7, has a unit cost of $4.2 million in the Navy's budget for the 2025 fiscal year. With such expense, fewer of these units are produced. Only about 50 per year were made in 2017, the year after the Mod 7 was introduced. The war in Ukraine has revealed how high the depletion rate is in a war against a peer or near-peer adversary, even with weapons significantly cheaper and easier to manufacture than these anti-ship missiles and torpedoes. Ukraine's hunger for 155mm artillery shells might be the best example. Having cheap and abundant weapons on hand to deal damage to more costly systems has proven essential for an effective fighting force. This is why Ukraine's drone pilots have been such a boon for its war effort. These drones can be made quickly and destroy tanks worth millions of dollars on the cheap. The Air Force intends the quick-sink to carry out the same type of mission against even more expensive targets. Ship-killing torpedoes also have limited flexibility. The Mark 48 can only be delivered via submarine, and while the United States has the world's premier submarine force, those vessels might not be conveniently nearby to respond to an emergency. They also need to get into range that could potentially be dangerous to deliver their payloads. But the quick-sink helps to get around all of these limitations. First, it takes a cheap weapon and turns it into a smart killer. For example, the United States introduced the Mark 84 bomb in the 1950s. It has a large surplus of these that have been in storage for decades. New ones are easy to produce too, with a unit cost of $16,000 in 2021. Adjusting for inflation, the price will be about $13,500 2024 dollars. The addition of a JDAM kit would cost an additional $25,000. There are a lot of these JDAM kits lying around too. Boeing has made at least 500,000 of them since 1988. Now Rimpak has proven that these cheap weapons can destroy large ships that can cost billions, all while delivered from a stealth bomber over a dozen miles away, long enough of a range for it to avoid most dangers. The delivery platform can also respond to a mission at any time, providing more flexibility. The operation against the Tarawa was not the only successful test of the quick-sink at Rimpak 2024. The USS Dubuque was also a target. This ship was commissioned in 1967 as an Austin-class amphibious transport dock. These types of ships are designed to support landing operations by carrying troops and equipment to hotspots. The Dubuque displaced 9,201 tons while light and weighed nearly 17,000 tons at full displacement. Though much smaller than the Tarawa, the long decommissioned ship was also sunk at Rimpak with a B-2 delivered JDAM bomb, proving that the bomb can hit a variety of targets. The Air Force Research Laboratory, the organization behind the quick-sink, described what it would add to America's defense posture. Quick-sink is an answer to the need to quickly neutralize menacing maritime threats over vast areas around the world. Everybody knew who the message was meant for. Things get worse for China if it has ideas to get more aggressive. The B-2 Spirit can hold far more than one quick-sink. It can carry 16 Mark 84 JDAM bombs in total, so it has shots to spare. If ever deployed, more than one enemy ship could come under the B-2's sights. A B-2 operating from Andersen Air Force Base in Guam is now capable of responding to this mission on short notice. With a vaster fleet of B-21s coming in the 2030s, this capability will increase. The Air Force's quick-sink plans don't stop at bombers either. The service also wants to create anti-ship tools capable of being launched from fighter aircraft like the F-35A and presumably the NGAD. Although these fighters would likely not be able to carry bombs big enough to sink carriers in one shot while maintaining their stealth profiles, they will still pose a danger to other important ships. They would also significantly increase the flexibility for delivery of quick-sink bombs. Aside from the small number of aircraft, one of the limitations involving B-2 delivery for quick-sink is that there are only a few locations capable of hosting the Spirit.
These bombers require specialized, climate-controlled hangars to maintain their stealth coating. Nearby bases capable of hosting the B-2 include the aforementioned Guam and the facilities at Diego Garcia, but it could still take hours for the Spirit to get to a hotspot from these locations. Most B-2 bombers are concentrated in Whiteman Air Force Base in Missouri, thousands of miles away from a potential flashpoint. The B-21 may be more robust as stealth technology has advanced since the B-2 was cutting edge, and the Air Force plans for there to be enough of them around the world to respond to an emergency, but the addition of quick-sync capabilities with faster fighter aircraft that can be stationed anywhere would make the new tool even more formidable and is likely a high priority. Adding quick-sync bombs to fighters stationed in Japan or the Philippines would be a significant obstacle for China to overcome if it intended to threaten Taiwan. The Air Force is also experimenting with adding even longer range to its quick-sync ability. In 2023, Boeing announced its intention to turn JDAM bombs into cruise missiles. This transformation would come through the Powered Joint Direct Attack Munition (PJDAM) concept. The company completed wind tunnel testing of the PJDAM that August and started to create digital models of the munition that would support further development. The PJDAM would have 4 parts: a jet engine, a pair of pop-out wings, the GPS-guided inertial navigation system found on a typical JDAM, and the standard low-drag bomb as the warhead. A typical wingless JDAM might have a 15-mile range. An extended-range JDAM with pop-out wings might have a 45-mile range. The PJDAM would be able to hit targets 300 miles away. The 2023 PJDAM tests involved 500-pound bombs. These smaller munitions can be carried on fighter aircraft, including in the internal weapons bays of the F-22 Raptor and F-35 Lightning II, and the NGAD and F-A XX in the future. These weapons would pose a significant threat to smaller ships, but likely not an aircraft carrier. It's not yet known if there are plans to scale the PJDAM concept up to the 2,000-pound Mark 84 to threaten larger vessels, as seen at RIMPAC. For one, the engine would need to be made larger, likely making it less than ideal to be carried on a stealth fighter. Still, with anti-ship weapons now being a high priority for the Air Force, it would not be surprising if the larger PJDAM becomes a project in the near future. It would be an ideal weapon to fit on the B-21 fleet. The PJDAM would also be comparatively cheap. Although the total price tag would likely run into 6 figures per unit thanks to the addition of a jet engine, the final per-unit price tag would still be much cheaper than a typical cruise or anti-ship missile or the Mark 48 torpedo. Against a large navy like China's, that could come in handy. Between the AIM-174B and the B-2 delivered quick-sync, RIMPAC 2024 revealed that the US military was thinking about how to use old weapons for new purposes. The AIM-174B was once thought to be a ship-based missile only, but now it can be launched from an aircraft, extending its range and potential to disrupt China's so-called kill chain, the web of systems and technologies required for a munition to deliver force to a target. Similarly, the JDAM bomb, once a linchpin of air support for ground forces, has now proven itself a potent anti-ship weapon, capable of rapidly sinking large vessels. Now, when contemplating their plans for Taiwan, China's military brass will have no choice but to wonder whether one of their aircraft carriers or other large ships required to support the invasion will be suddenly sunk by way of a bomber that they could not even see coming. But what do you think about the quick-sync delivered by way of stealth bomber? How will it influence the tense politics of the Indo-Pacific region? The mother of all bombs. Just hearing this name is enough to make anyone shudder. After all, this isn't just another weapon in the US military arsenal. It's a terrifying force of destruction, one of the deadliest bombs ever built. There are nations around the world that are well aware of its power. They know what happens when this bomb drops. They've seen it. But for Iran, the fear cuts even deeper. Why? Why is Iran in particular terrified of this bomb? What is it about this monstrous weapon that keeps Iranian leaders awake at night? Keep watching to find out. The fear surrounding this bomb isn't just about its name, it's rooted in its raw power. While it's referred to as the mother of all bombs, that isn't the device's official name. It's officially known as the GBU-43B Massive Ordnance Air Blast, or simply the Moab. Doesn't quite have the same punch, does it? Well, the ominous nickname actually came from Iraqi President Saddam Hussein, who once spoke of the mother of all battles during the Gulf War. But now the US military has taken that phrase and bomb technology to a whole new level. So what is the mother of all bombs? The Moab is a large-yield bomb developed by Albert L. Wymorts Jr. from the Air Force Research Laboratory. Despite what its name might suggest, the Moab isn't a nuclear device, which is crucial to understand. Why? Well, because Moab is frequently lumped together with nuclear weapons whenever there's talk about the destructive power of these devices. This misunderstanding has muddied discussions about the bomb's true purpose, which we'll talk about later in the video. While the effect of the Moab might seem nuclear in scale, this bomb is very much a conventional weapon.
But what a weapon it is! This thing is a behemoth, 30 feet long, 22,600 pounds, and packed with 18,700 pounds of H6 explosive. These specs make it more than just a bomb, we're talking about a force of nature. And this isn't even the heaviest non-nuclear bomb in the US arsenal. That title belongs to the Massive Ordnance Penetrator or MOP, a truly colossal 30,000-pound bunker buster, designed to tear through hardened targets. But back to the Moab. Its sheer size isn't the only thing that's impressive about this bomb. Its explosive power is also staggering. The Moab uses H6 explosives, originally developed for underwater blasts because it's shock-resistant and stable. And let us tell you, this bomb is packed with explosives. In fact, it carries the largest amount of explosive in any non-nuclear weapon in the US military inventory. To put that into perspective, compare it to the Joint Direct Attack Munition, JDAM, a frequently used precision-guided bomb. The JDAM weighs between 500 and 2,000 pounds and carries only a fraction of the explosive power found in the Moab. The difference between the two is almost shocking. The JDAM can cripple a target severely, but the Moab, it can wipe it off the map entirely. Now, this comparison between the JDAM and Moab might seem odd, but this is only due to the misconception that the Moab is a so-called dumb bomb, lacking precision and guidance. And sure, there were reports of the bomb being deployed by kicking it out of the back door of the MC-130 aircraft, which might make it sound like a crude barrel bomb approach. But that's far from reality. The Moab is actually a guided munition. After it's dropped from the cargo doors of an MC-130 transport plane, a parachute deploys, slowing its descent. Then, the weapon detaches from the pallet and GPS satellite guidance kicks in. The Moab is guided to a predetermined target by its onboard avionics, ensuring impressive accuracy. This is a far cry from the days of the so-called daisy cutter bombs, unguided bombs used in Vietnam that created massive blast zones without any precision. The Moab, on the other hand, has it all: the explosive force and the accuracy of modern guidance systems. It's no longer about random devastation, it's about surgical, controlled destruction. The bomb is stabilized by 4 grid-like fins and glides to its target, ready to unleash its power at the exact location and the exact moment it's needed. But what are the locations targeted by the Moab? Well, the Moab is designed to strike certain types of targets, mostly located in hard-to-reach places. Think of underground facilities and deeply entrenched tunnel systems. However, this leads us to another common misconception about the Moab, that it's a bunker buster. No, the Moab isn't a penetrator, which means it won't drill through rock or hardened concrete. Instead, this device is an airburst weapon that detonates above the surface to maximize its destructive radius. This makes it ideal for softer or medium resilience targets like canyon floors, mountainsides, or the rugged hideouts that enemies might build deep within cave systems. Just imagine a bomb descending into a canyon or toward the mouth of a cave. When it explodes, it sends an immense pressure wave crashing into every crevice, engulfing anything and anyone within reach. Now, in terms of coverage, it's not quite the same as a high-altitude bomber mission. Heavy bombers like the B-52 or B-2 can cover far larger areas by dropping multiple smaller 500 to 2,000-pound bombs, thus blanketing a target. During the Vietnam War, for example, the US Air Force conducted over 10,000 of these bombing raids using B-52s. During a typical raid, 2 groups of 3 aircraft would drop around 168 tons of ordnance, raining terror on an area 1.5 by 0.5 miles. The explosive force of a single raid was equivalent to 10 to 17 Moabs. But the Moab was never intended to replace those types of attack. It was always created for precision on a grand scale, delivering destruction over a focused area in one catastrophic blast, the kind that would be wasted on an open battlefield but devastating in enclosed environments. This brings us to another crucial use of the Moab: psychological terror. You see, the Moab's massive mushroom cloud mimics the notorious, haunting image of a nuclear detonation, a visual designed to shock and intimidate. During its development in 2003, which we'll also discuss in a bit, the Moab was prepared as a psychological tool for potential use in Iraq, where the US intended to intimidate troops and break enemy morale. In this regard, the Moab developers took cues from the infamous 15,000-pound BLU-82 bomb used in Vietnam and later in Afghanistan to devastating psychological effects. Seeing the impact the so-called daisy cutter had on terrifying adversaries, military strategists set out to create an even more powerful tool for psychological warfare, and they did just that. Seeing the Moab in action, or even just hearing about it, can send a powerful message. It signals that any resistance will be met with an overwhelming show of force, and this is a message that Iran understands all too well. So the Moab's very existence is enough to keep this country and its ilk on edge.
After all, we're talking about more than a weapon. We're talking about a reminder of the potential scale of US military power and the readiness to deploy it whenever necessary. However, the horrors of the Moab go well beyond the visual. Its primary effect is a massive blast wave, one said to stretch for up to a mile in every direction, generated by the bomb's staggering 18,700 pounds of TNT. But this isn't just a typical explosion. The bomb's thin aluminium casing maximizes the blast radius, allowing the force to extend over an enormous area instead of being confined by heavy metal that might limit its spread. When the Moab detonates, an immense fireball erupts, causing immediate destruction, in another similarity with nuclear weapons. However, it's the pressure wave that delivers the Moab's true devastation. As mentioned, the Moab detonates above the ground, which allows its force to radiate across the surface. This approach maximizes the area affected, making it deadly for personnel in open areas and lethal, even for those in hardened defenses. Essentially, the pressure wave, fueled by high-temperature gases released in the blast, flattens everything in its path. For those caught within the blast radius, the injuries are particularly gruesome. The wave impacts gas-filled structures in the body, lungs, ears, and the gastrointestinal tract, causing internal injuries that can be fatal. Used against a cave system, the Moab's pressure is even more sinister. It can cause tunnel collapse, trapping or killing those inside, and even if the tunnels hold, the wave can penetrate, injuring anyone within range simply by the sheer force of the shock. But how did this destructive device come to be? We've already mentioned that it was developed for potential use in the Iraq War, also referred to as the Second Gulf War. However, the bomb was never used in Iraq, serving instead as a looming threat, and for Iraq's next-door neighbor, Iran, the message was unmistakable. This weapon exists, and it's ready. The Moab underwent its first test at Eglin Air Force Base in Florida in March 2003. The blast was downright shocking, a display of destructive power designed to unsettle anyone aware of its potential. Since 2003, at least 15 Moabs have been manufactured at the McAllister Army Ammunition Plant in Oklahoma. This figure lines up with the bomb's actual cost, which the US Air Force estimates at approximately $170,000 per unit. This relatively low price stems from using existing parts, materials, and an efficient in-house production process. While earlier reports had inflated the cost to as much as $16 million per bomb, this figure was widely misreported and didn't reflect the streamlined methods used to create the Moab. Truthfully, the first Moabs were built as a crash project meant to meet urgent demand. That's why they sidestepped standard procurement and research costs. Today, manufacturing costs are much higher. With older parts unavailable and factoring in inflation, building more Moabs would require fresh design efforts and rigorous testing, making this bomb not only rare but extremely expensive to reproduce. As a result, it's unlikely we'll see this bomb used frequently, making each deployment a high-stakes decision designed to command attention. Interestingly, this decision doesn't have to come from the President of the United States. Why? Because the Moab isn't a nuclear weapon. In fact, the first and only time the bomb was used, the strike wasn't directly authorized by the president at the time, Donald Trump. When asked if he personally authorized the strike, Trump responded, "Everybody knows exactly what happened. What I do is authorize my military. We have the greatest military in the world, and they've done a job as usual. We've given them total authorization, and that's what they're doing, and frankly, that's why we've been so successful lately." Though Trump didn't directly say whether he signed off on the specific use of the Moab or not, his comments make it abundantly clear that the decision didn't necessarily require his direct approval. A senior administration official further clarified, "We don't approve every strike," noting that the Trump administration had moved away from micromanaging military strategy. Trump was also the one who pushed for this shift, granting military leaders more independence. That's why the first use of Moab was reportedly approved by General John Nicholson, the commander of US forces in Afghanistan, after receiving the green light from General Joseph Votel, the commander of US Central Command at the time. But what is this first and only use of the Moab we keep mentioning? The first time the Moab was used in combat was in 2017 against another one of Iran's neighbors, Afghanistan. The target, a vast network of tunnels used by the Islamic State, Khorasan province, ISIS-K, had become a major threat to both US and Afghan forces in the region. These tunnels, which had originally been built by the CIA in the 1980s for the Mujahideen, were a significant advantage for ISIS-K, allowing them to stay hidden, plan, and strike unexpectedly. Since the Islamic State's Khorasan branch established its stronghold near the Afghan-Pakistani border, it was incredibly difficult for ground forces to control the terrain and neutralize the threat. The Afghan National Army Commando Corps tried for months on end, but the ISIS-K remained entrenched in the rugged, heavily fortified terrain, often using improvised explosive devices to slow progress. Prior to the explosion, Afghan forces had struggled to penetrate the area for weeks. Traditional approaches were essentially useless due to the region's difficult-to-access geography. However, even airstrikes and drones have been unsuccessful in taking out these fortified hideouts, so eventually, the US military turned to its ultimate weapon at the time, the Moab. The mother of all bombs was dropped on the rugged mountains of Achin district, Nangarhar province, on April 13th at exactly 7:32 p.m. local time from the rear cargo door of an MC-130. The explosion was unlike anything most had ever witnessed. Afghan residents nearby reported feeling the earth shake as if an earthquake had struck. This is precisely how an Afghan soldier driving toward the targeted area described it, saying, "The explosion felt like a big earthquake, even in the surrounding districts." The blast itself was so powerful that it lit up the sky with a massive fireball, and the ensuing mushroom cloud could be seen for miles. As for the sound, the locals described it as the biggest blast they'd ever heard. One local man recounted, "I've grown up in the war, and I've heard several kinds of explosions through 30 years, suicide attacks, earthquakes, different kinds of blasts. I've never heard anything like this." Now remember how we said that ISIS-K became a threat to Afghan soldiers as well? Well, the Afghan troops were actually in on the strike, working closely with US Special Forces to ensure its precision and effectiveness. Local tribe elders were also warned to evacuate civilians ahead of time to minimize any collateral damage. Essentially, the Moab strike was a joint effort between the US and Afghan forces, who also moved in to clear the area together in the aftermath of the explosion. But what was the aftermath of the explosion? Well, for one, the system of tunnels and caves used by ISIS fighters to move around freely and target US military advisors and Afghan forces in the area, as Trump's spokesman Sean Spicer put it, was obliterated. This was of the utmost importance, as defeating ISIS, according to Spicer, meant denying it operational space, and that's what the Moab did. The Moab also took out the ISIS militants hiding in the tunnels. Now, after the massive explosion, casualty reports were a bit of a moving target, with figures increasing over time as more information came in. On one side, the Afghan army proudly reported that 94 ISIS-K militants were killed, including 4 high-ranking commanders, with no signs of civilian casualties. This was, of course, the official narrative from the Afghan army, which has every incentive to downplay civilian loss. However, the situation wasn't so cut and dry. On the other side, a local Afghan parliamentarian, Esmatullah Shinwari, painted a different picture. Locals, he claimed, reported the tragic death of a teacher and his young son, both caught in the blast's wave. Residential buildings as far as 1.5 miles away also suffered damage from the blast. As the days went on, more casualties were reported, with the total climbing to 96 ISIS-K militants by April 18th. Among them, as it turned out, were 13 major commanders. According to the Afghan Defense Ministry, several foreign nationals, Indian, Pakistani, Bangladeshi, and Filipino militants were also killed. However, ISIS wasn't buying this story. The ISIS-affiliated Amaq news agency flatly denied that any militants were killed in the strike, a clear indication that they weren't about to give the US military any PR wins. So let's say the true toll of the Moab explosion remains a bit murky, caught between military reports, local accounts, and the larger-than-life scale of the blast. One thing was still pretty clear though: the Moab sent a message, and everyone in the region felt it, Iran included. That's probably why just a few months later, in September 2017, Iran started claiming that it had developed the father of all bombs. Iran's 10-ton bomb was being presented as the country's answer to the Moab, just as devastating, just as destructive. General Amir Ali Hajizadeh, the commander of Iran's airspace force, bragged that this bomb could be launched from aircraft and had immense destructive potential. But here's the kicker: Iran wasn't the only one trying to match the Moab's power in a desperate attempt to conceal their fear. About a decade prior, in 2007, Russia had also unveiled its own father of all bombs. This bomb was being billed as 4 times more powerful than the Moab, thanks to its thermobaric design, which creates a deadly vacuum after detonation. This vacuum pulls air out of the target, making it particularly deadly in confined spaces like tunnels or bunkers. It was Russia's way of saying, "We can do it bigger." So, like Iran, Russia wasn't focused on practical application, it was just sending a message. However, the US military knows a thing or two about sending a bone-chilling message, one that resounds long after the dust settles. That's why Iran is so terrified of the mother of all bombs. The Moab is a bit of a dramatic flourish. It isn't the first bomb you drop, it's the grand finale. It's the ultimate statement that says, there's no place to hide. But before this statement comes, the US has sent lots of smaller messages that are just as direct. Take the B-2 bomber strikes in Yemen as an example. In 2024, US B-2 bombers targeted underground Houthi weapons storage sites, sending a message that only that stealth bomber could. The B-2's long-range strikes aim to dismantle the Houthi threat in Yemen and demonstrate a potent form of deterrence, America's ability to hit deeply buried, hardened sites anywhere in the world, no matter how well protected they are.
These strikes were a reminder of US dominance in military technology, specifically highlighting the penetrating power of its munitions, which can destroy some of the most reinforced bunkers in existence. Now, you might wonder, how is targeting Yemen sending a message to Iran? Well, you see, Iran has long supported Houthi militants in Yemen, using them as a proxy in its ongoing rivalry with US interests in the region. The Houthis, with their underground bunkers and fortified positions, represent the kind of threat Iran could pose if tensions with the US were to escalate. The same goes for other Iranian proxies in the region, groups like Hezbollah in Lebanon or Shiite militias in Iraq. By demonstrating its ability to obliterate such underground networks in Yemen, the US is essentially drawing a direct line to Iran. Escalate and we'll target your fortified positions, no matter where you hide them. Of course, this is a major issue for Iran, as the country's nuclear and missile programs heavily depend on underground facilities. Now, the Moab might not be able to penetrate facilities like the Fordow fuel enrichment plant and Natanz enrichment complex, buried deep within mountains. However, the sheer scale and destructive power of this bomb can obliterate everything that lies above the ground, leaving no stone unturned. It can also create a massive shockwave that would disrupt critical communications, military operations, and infrastructure within a large radius, weakening Iran's ability to maintain control over its defensive systems. The Moab's power can also incapacitate entire command centers and missile launch sites, which are dispersed across the country. This makes it an extremely effective tool against Iran's surface-level military assets, which are often the first line of defense for its more strategically critical underground facilities. The threat of such a devastating strike would also have a paralyzing effect on Iranian decision-makers. They have been panicking for a while now, trying to engage with other countries in the Middle East to secure support for their regime. Iran's leadership knows that if its fortified missile silos and nuclear sites are targeted, this could be the end of the country's nuclear program as it stands. And this is precisely what the US wants. You see, the US has repeatedly stated that it intends to prevent Iran from obtaining a nuclear arsenal. With Iran's breakout time, the period it would take to accumulate enough fissile material for a nuclear bomb, now reduced to a matter of weeks, the threat is even more immediate. The Moab could serve as a powerful deterrent to this very scenario. It would signal to Iran that any further steps toward nuclear escalation could provoke the full force of US military capabilities. This full force, of course, includes the massive ordnance penetrator, which would have no issues obliterating facilities like Fordow or Natanz. However, even the Moab alone could cause quite the amount of damage. Unlike what happened in Afghanistan in 2017, the US wouldn't exactly have the luxury of choosing isolated targets devoid of civilian presence. Iran's strategic facilities are often located near populated areas, and the deployment of Moab in such contexts would undoubtedly impact nearby civilian infrastructure and, of course, the civilians themselves. This reality amplifies the bomb's psychological impact, which is also one of its key purposes. The Moab wouldn't be used solely to cause physical destruction. It's intended to instill a sense of vulnerability into the heart of Iran's defensive posture. And if just the thought of this explosion already has Iran scrambling to consider other options, then its actual deployment would shake Tehran's strategic calculations to the core. But what do you think? Will this explosion eventually take place? And if it does, will it truly shift Iran's defensive posture, or will it only deepen its resolve? Despite Russia and China investing so heavily in their militaries over the last 2 decades, the United States stands alone as having the most advanced forces in the world. And nowhere is that truer than with the US Air Force. Of America's 5 major armed forces branches, the Air Force consistently receives the most money every year. In 2024 alone, it'll get $216.1 billion, with only the Navy coming close with its $202.6 billion budget. That money goes toward buying and developing the most advanced aircraft around, as well as training pilots to make the most out of those craft. But does that mean the US is unbeatable in the air? That's the question we aim to answer in this video, as we stack America's Air Force against its Russian and Chinese equivalents. In a straight fight, with no other armed forces branches involved, who would come out on top? We'll start with the raw numbers. Every year, Global Firepower, or GFP, creates a new annual review in which it analyzes the militaries of 145 countries to come up with rankings for their overall strength. The US, Russia, and China rank at numbers 1, 2, and 3 respectively, with all 3 having impressive air forces in terms of sheer number of assets. Starting with the United States, GFP says that it has a staggering 13,209 aircraft in its stock, though only 9,907 of those craft are combat-ready. It has 1,854 fighters to go along with 896 attack types. Plus, it's unparalleled when it comes to the number of fixed-wing transports it has, an enormous 957 craft dedicated to moving troops around. Switching the focus to helicopters, the US has 5,737 military choppers, with a further 1,000 dedicated to attack. Throw in 695 special mission planes, and the picture is clear. The United States ranks number one across the board for its sheer number of aerial assets. And it doesn't end there. As well as having the largest aerial fleet in the world, the US does a better job of transporting its planes around the world than any other country. GFP says that it has 11 aircraft carriers and 9 helicopter carriers, with each being capable of holding dozens of aerial assets that can be sailed almost anywhere. For the US, achieving aerial dominance isn't just about having the most planes and choppers, it's about ensuring those assets can get to where they need to go so the country can make the most out of them. But what about Russia? GFP says its air force is around a third of the size of America's, with the country having 4,255 aircraft in stock, of which 2,766 are combat-ready. The US beats it by over 1,000 when it comes to fighters, with Russia also having around 170 fewer attack-type planes. It has half the number of transports and about a quarter the number of helicopters, with Russia essentially losing out by a substantial margin in practically every category. Add a lack of transport options, it only has 1 aircraft carrier and no helicopter carriers, and Russia's air force is less capable than America's when it comes to responding to issues further afield. China doesn't fare much better. It has even fewer aircraft than Russia, with 3,304 in stock, of which 2,478 are combat-ready. It's doing a better job of building fighters though, with the 1,207 it has coming a little closer to the US total and its 1,854. But it has far fewer transports, helicopters, and special mission craft. Plus, like Russia, it underestimates the importance of being able to transport its aircraft around the world. China only has 2 aircraft carriers and 3 helicopter carriers. So it's clear that the US can beat either Russia or China when it comes to pure numbers. But what's most interesting about GFP stats is that Russia and China combined still don't quite match up to the might of the US Air Force. The 7,559 aircraft the two countries have in stock is still more than 2,000 fewer than the United States has, with the US also handily winning in terms of being able to transport its planes around the world thanks to having 11 aircraft carriers to Russia's and China's combined 3. What does all this tell us right off the bat? In a war that sees the United States transporting troops to Russia or China, it will be able to provide far better support to those troops thanks to its aircraft carriers. It also wouldn't have to worry about losing the numbers game. It has either triple or quadruple the number of aircraft at its disposal, depending on if it's fighting Russia or China, as well as a powerful navy capable of protecting its carriers in the water. It's not looking good for Russia or China so far. However, the true measure of an air force's strength doesn't solely lie in the number of aircraft it has. Quality is also important. So let's stack some of America's most important planes up against their closest Russian and Chinese equivalents. We start with what may be the most famous American fighter of all, the F-16. There's a good reason why Ukraine has been so desperate to build a stockpile of these multi-role fighters to help it fight its war against Russia. The planes are capable of flying for up to 500 miles without needing to refuel and can carry a pair of 2,000-pound bombs, along with 2 AIM-9 and 2 AIM-120 missiles. They have a 50,000-foot ceiling and are capable of reaching Mach 2 speeds, meaning their top speed of 1,500 miles per hour doubles the speed of sound. They also come in multiple varieties. The F-16C is capable of holding 1 pilot, while the F-16D can hold 2. The US has also iterated on the design multiple times since the plane's 1979 introduction, with more recent models even being capable of carrying nuclear weapons. The F-16 isn't the most technologically advanced fighter in America's arsenal, as you'll discover soon, but it's among the most versatile. That's probably why the US Air Force has ordered 2,256 of these craft since its introduction. So what are Russia and China's closest equivalent to the F-16? For Russia, the answer is probably the MiG-29. Taking its maiden flight 2 years before the F-16's introduction, though it wasn't brought into active military service until 1983, the MiG-29 can carry 2 R-27 medium-range missiles, along with 6 R-60 and R-73 short-range missiles. It's also capable of carrying heavier bombs, with Air Force Technology News stating it can hold up to 6,613 pounds of bombs. So that would make it stronger than the F-16, right? Not necessarily. Though the MiG-29 brings more firepower to the aerial party, its heavier weight and engines lend it some disadvantages. In a straight race, the F-16 has a 200-knot speed advantage, though the MiG-29 counters that with exceptional maneuverability that could help it track the F-16 in a slow-speed fight. However, the days of dogfighting, though not over, aren't what they were in the 1980s. According to the Eurasian Times, the F-16's radar systems make it much better at providing a situational picture to its pilot, allowing it to see the enemy first and shoot them down before ever engaging in a dogfight. Plus, the MiG-29's strong engines means it consumes fuel faster, so it can stay in the sky as long as the F-16. Add to that Russia only having around 600 MiG-29s in stock. They have lost some in Ukraine, and the F-16 appears to be the winner. Does China fare much better? Its closest equivalent to the F-16 is the J-10 Vigorious Dragon, a multi-role tactical fighter that entered service in 2005. It's available in single and double-seat configurations, just like the F-16. Also like the F-16, the J-10 can reach speeds of Mach 2, as well as having exceptional range. It can stay in the air for 1,150 nautical miles before it needs to refuel. On the surface, that would make the J-10 appear to be an even match for the F-16. However, that may not be the case. The F-16 hasn't stayed stagnant since its introduction in the late 1970s. The US Air Force has improved it several times over, including equipping the plane with new generations of radar, sensors, and weapon technology. There's even a specific project dedicated to these upgrades, the Service Life Extension Plan, or SLEP. Thanks to the SLEP, the F-16 will be flyable until at least the 2040s, with the newer and upgraded versions of these multi-role fighters being equipped with technology that is used in the F-35. And again, the numbers advantage comes into play, with China only having 565 J-10s compared to the thousands of F-16s the US Air Force has on hand. If the F-16 had never evolved, it would be roughly equivalent to the MiG-29, but thanks to its constant iterations, it's likely superior to Russia's multi-role fighter, in addition to being at least on par with China's. Now let's switch focus to jets that have stealth capabilities. For the United States, the F-22 may be the best stealth fighter it has. At 62 feet and with a 44-foot wingspan, it's larger than the F-16. It's also heavier. It weighs 43,340 pounds when it's unloaded. The jet can hit Mach 2 with supercruise capabilities and has a 1,600 nautical mile range. It's also lethal. The fighter comes backed with an M61A2 20mm cannon, as well as side weapon bays that can carry AIM-9 heat-seeking missiles. Up to 6 AIM-120 radar-guided missiles can also be loaded into the plane, but it's the engine that's the real standout. According to the US Air Force's official website, the F-22's engines create more thrust than any other fighter plane, which is key to allowing it to cruise at speeds of Mach 1.5 without engaging afterburners. But Russia's Su-57 isn't too far away from those specs. It's also capable of hitting Mach 2, even though it's a slightly larger craft at nearly 66 feet and with a wingspan of around 46 feet. The problem is that the Su-57 has experienced several production problems. The national interest says a production crash has limited Russia's ability to create more of these stealth jets, and even the ones it has, though similar in terms of specifications, still fall behind the F-22 in terms of maneuverability and stealth capabilities. It's also telling that the Su-57 hasn't been used regularly in Russia's war with Ukraine, despite Moscow claiming that it's the world's best combat aircraft. So there's an unanswered question here. Does the Su-57 live up to Russia's hype? We don't have answers yet, meaning it's up to China to try and take the F-22's crown as the world's foremost stealth fighter. But as with the Su-57, we only have Chinese claims of superiority to go on rather than real-world data. We do know that the J-20 appears larger than the F-22, at least according to Warrior Maven. However, its fuselage is almost a direct match. It has a 2-engine exhaust and a similar curved body to the F-22. But it doesn't have the supercruise capabilities that make the F-22 stand out, which means it doesn't come close in terms of stealth operations. After all, the F-22 can fly at Mach 1.5 without engaging afterburners that give its position away. As far as we know, the J-20 can't. China claims that the J-20 is faster at least, stating that it can reach speeds of Mach 2.55. However, these claims are unverified, and given that the US uses the F-22 as an aerial quarterback that dictates and controls operations, the faster top speed may not mean much operationally. So it looks like the United States can chalk up another win in the technology column. Now let's look at a fighter that's part of the US Air Force's future, the F-35. America's newest fifth-generation fighter, the F-35, will eventually replace the F-16 as the country's go-to multi-role jet. But that replacement is going to be a long time coming. For now, we know that the jet can hit a top speed of Mach 1.6 and can fly for 1,200 nautical miles using internal fuel alone. It's also one of the few planes in America's arsenal that wasn't developed solely by the United States. 8 other countries, including the UK, Netherlands, Canada, Denmark, Turkey, Italy, Australia, and Norway, have also contributed to the design, making the F-35 an icon of international cooperation. It also packs a lot of advanced technology. That's seen in the helmet-mounted display system, which provides targeting information and combat intelligence to the pilots as they fly. It's no wonder that the Department of Defense plans to field 2,500 F-35s at a cost exceeding $1.7 trillion during its life cycle. It already has about 450 in the field. As for Russia and China, they bring the Su-35 and the J-35 to the aerial theater, though the comparisons aren't perfect. For instance, the F-35 is designed to be a stealth fighter, while the Su-35 is stronger as a straight fighter. But as we mentioned earlier, that could play in the F-35's favor. Pilots are increasingly moving away from dogfighting in favor of a see first then shoot approach to aerial combat. So an F-35 is unlikely to engage an Su-35 one-on-one unless forced to do so. It's far more likely, the Eurasian Times points out, to attack before the Su-35 knows it's there or try to escape it if it risks being forced into a dogfight. As for the J-35, also known as the Shenyang FC-31, there's very little known about China's fighter. Though it's rumored to now be deployed on the country's aircraft carriers, it's so new to combat that it's difficult to truly compare how it stacks up to the F-35. However, the national interest provides some snippets of information, with the most interesting being that China is apparently intending to sell the J-35 to countries that find the F-35 to be too expensive. That would suggest the J-35 doesn't pack the same technological muscle as its American rival, though it's no slouch. It has a wing-fold mechanism and uses a catapult launch bar, as well as being capable of taking off from an aircraft carrier. But beyond that, there's not a lot of information. American officials believe the J-35 will likely be capable of taking on and defeating fourth-generation fighters like the F-16, but when stacked up against the F-22 or F-35, it may come out on the short end. One thing from the comparison is clear. Though China and Russia have fifth-generation fighters of their own, the F-35 is the only one with proven combat capability so far. Most of what we know about the J-35 is rumor, with the Su-35 appearing to have been designed for a form of air combat that is quickly losing steam in terms of its strategic use. So far, we've restricted our focus to fighter jets. Though they're the most glamorous aircraft in an air force's arsenal, they're far from the only ones that matter. Bombers are also extremely important, particularly for supporting ground troops, or in worse cases, dropping nuclear weapons on an enemy. That's where the B-2 Spirit comes into play for the United States. A multi-role bomber that's capable of dropping both conventional and nuclear bombs, the B-2 has been operating since April 1997. It's a behemoth of a plane, weighing 160,000 pounds when empty, but capable of taking off at a maximum weight of 336,500 pounds. It can carry a 40,000-pound payload and reach high subsonic speeds. As for the range, the US Air Force website offers just one word: intercontinental. Russia doesn't currently have anything that truly compares to the B-2 Spirit. Its Su-34 fallback is a combined fighter-bomber that's able to carry out bombing runs over medium range. But it's nowhere near as large as the B-2 Spirit, meaning it can't carry the same weight of payload. Plus, it can't fly as far. That may be why the US Air Force doesn't really have a direct equivalent, with the F-15 and F-111 offering the closest comparisons, as it has no real need for it. Other than that, the Tu-160 is Russia's closest equivalent to the B-2. It entered production in the 1970s, though didn't see service until 1987. And even then, Russia restricted it to very limited production runs that have made it a near non-factor in its air force. It's difficult to see why, especially as the Tu-160 is faster than the B-2, but it's likely due to high production costs combined with a lack of utility. So, though the Tu-160 can hit 1,380 miles per hour compared to the B-2's 630, as well as having similar stealth capabilities, the fact that Russia only has 20 in its arsenal suggests that it doesn't even see a point in competing with the US with this plane. As for China, its closest equivalent to the B-2 is the Zhan H-6. and frankly the United States easily wins this comparison as well. The H-6 doesn't have the B-2's stealth capabilities and only has about half the range, about 3,720 miles compared to the B-2's 6,900. It is a little faster though, and only requires half the crew. However, that's because it's a much narrower bomber, which puts limits on its potential payload. It could still do a decent job if China were able to fly it over the US mainland, though that's unlikely because the lack of stealth means the US Air Force would see it and shoot it out of the sky before it had a chance to drop its bombs. So in the stealth bomber department, America's competition is either a bomber that experiences constant production delays or one that actually has no stealth capabilities. Another easy win for the US Air Force. And so we come to the final American aircraft that's worth noting for this comparison, the B-21 Raider. We're turning our attention to the future here, as the B-21 is still in development, with the US Air Force expecting it to enter operation at some point during the mid-2020s. A double-penetrating stealth bomber, the plane can carry both nuclear and conventional munitions, and will join the upcoming B-52 to become part of the backbone of America's aerial bombing sector. Think of it more as an efficiently designed version of the B-2. Aviation Week points out that there's a clear resemblance between the two planes, though the B-21's 132-foot wingspan makes it the smaller of the two. It's also far lighter. Its empty weight is about half of the B-2's. Despite that, it has a huge weapons bay and will be capable of reaching speeds of Mach 0.8 when in the air. Russia's closest equivalent, the PAC-DA, is also still in development. It can reach subsonic speeds topping out at around 559 miles per hour, with a service ceiling believed to be around 78,000 feet. It's also anticipated to enter operations at some point in the 2020s, though there's far less information available about it than for the B-21. It also doesn't appear to be capable of dropping nuclear weapons, with its focus being on X-45 air-to-surface missiles, anti-ship missiles, and precision bombs. However, that may change in the future. The bomber is still under development, and its specs may evolve over time. As for China, it's currently working on the H-20. However, Warrior Maven highlights an immediate issue that China might have with this bomber. It's designed as a B-2 copycat, rather than a plane that's capable of taking on the B-21. Still, you could argue that the B-21 itself is a copycat, given that it shares so much of its design with the B-2. Plus, the H-20 should give China an intercontinental range, as well as offer it the ability to drop nuclear weapons on overseas targets. Its range is lower than the B-2's. The H-20 can travel for 5,280 miles, which could mean it would end up being far behind the B-21 when the craft is finally properly introduced. However, the Pentagon also suggests China is working to turn it into a refuelable bomber, which could put it beyond the B-2's range capabilities. As with the F-35 comparisons, we're now veering into speculation. For now, the US seems to have the superior upcoming bomber, though that may be simply because we know more about the B-21 than we do about the H-20 or PAC-DA. What's clear at this point is that Russia and China are still playing catch-up with the US Air Force. That's a game it can't hope to win. As they develop new planes that mimic what America has, the US will be hard at work creating new assets for its Air Force that beat out those Russian and Chinese craft. That brings us to 5 words that hint at the likelihood that the US will dominate China and Russia in the air for years to come. Next Generation Air Dominance Program, or NGAD. Instituted in 2014, NGAD is a top-secret program that's believed to have seen around $16 billion in investment so far and will likely receive billions more in coming years. The program focuses on the development of a 6th-generation fighter even before the US has properly implemented its 5th-generation jets, and it's interesting to see how America is looking to completely change the entire concept behind aerial combat with this plane. Air Force Technology says that NGAD will result in the development of a new fighter, though that isn't the real headline. What's most important is that the fighter will be part of a family of systems that will include several other manned aircraft along with unmanned aerial vehicles that can act as the upcoming jet's wingmen. The idea is to move away from the single-platform focus the US Air Force has followed in aircraft design in the past. Instead, its newest fighter will actually be an entire interconnected system of aerial assets that work in tandem to establish aerial dominance. Little is known beyond that, other than each NGAD fighter will cost an estimated $300 million to produce, and that the Unmanned Collaborative Combat Aircraft, or CCAs, will fly with the NGAD and seamlessly receive instructions from the NGAD's pilot to do whatever they need them to do. In essence, one pilot will be flying multiple aircraft at once, allowing them to attack with a force of several. As for those CCAs, it's believed that they will carry a multitude of sensors, along with electronic warfare weaponry and a host of munitions to support the main fighter jet controlling them. That makes them multi-role. They can shoot, sense, jam, and even perhaps act as diversions to pull enemy missiles away from a manned fighter. Again, we see America's technological dominance coming into play. While Russia and China are still trying to play catch-up, both in terms of sheer numbers and the quality of their craft, the US is moving into a sixth generation of aerial warfare that promises to be paradigm-shifting. And we're not done. After all, a plane or helicopter is only as good as its pilot, so our final area for examination lies in what makes a pilot: their training. For an American pilot who wishes to fly a fighter jet, that training takes several years. Before they can even apply for fighter school, they must earn a bachelor's degree and join the Air Force, a process that can take over 3 years. Once in the Air Force, the prospective pilot must meet several criteria, including demonstrating a solid understanding of flight theory and completing the United States Air Force undergraduate pilot training program. And they're still not done. From there, the pilot has to become an officer, with 3 options available: Air Force Academy, Officer Training School, and Air Force Reserve Officer Training Corps. They'll also need to pass a single-scope background investigation, meaning those with criminal histories may not be able to join. Plus, there are age and height requirements. The pilot must be between the ages of 18 and 33 when they start their training, with their height having to align with the jet they want to pilot before they can start. It's an intensive training program. And it all has to be completed before the pilot can even be considered to fly out on operations. Russian flight training is similarly intensive. While there's little information available about the prior qualifications a prospective Russian pilot needs, we know that they'll study for 5 years at Krasnodar Higher Military Aviation School of Pilots, or KVAL. The first 2 years of training at KVAL focus on theory, with the pilot not even getting to climb into a jet until their 3rd year. During the final 3 years of training, they'll fly multiple jets, including the Yak-130, L-410, and AN-26, logging around 120 hours in the air before they're considered for the field. As for China, it reportedly accelerated its pilot training program in 2022. Previously, a China pilot would spend between 4 and 6 years in training before they took to the skies for missions. However, the Eurasian Times reports that the country's new program, operated at the Shizhezhuang Flight Academy, sees pilots training in a J-10 fighter for 3 years. Is that enough? Both the Russian and American training programs take around 5 years, accounting for studying for a relevant bachelor's degree for the American program. So a Chinese pilot may log fewer hours in their jet during training than a US or Russian equivalent, though China's training programs are so secretive that it's difficult to tell. Either way, it's clear that the US has a very strict program that is at least equal, if not superior, to the programs that Russia and China operate. So the US comes out on top in every category. Its Air Force is substantially larger than Russia's or China's, and is even larger than the combined forces of both countries, and it has better planes. Its pilots undergo extensive training, ensuring they're prepared for anything they'll encounter in the air and understand their flight systems inside and out. Plus, the US is ahead of the technological curve. Its NGAD program is moving into the 6th generation of fighters, while Russia and China are still focused on the 5th. Combine all of that and you reach a simple conclusion. Russia and China don't stand a chance of beating the US Air Force. But what do you think? Does the United States truly reign supreme in the skies due to all of the points highlighted in this video? Or do you think a battle for aerial supremacy with Russia or China would be so complicated and location-dependent that it's difficult to tell who would come out on top without it actually happening? China and the US have amassed incredible armies that are stocked with the best equipment and weapons that money can buy. But whether there will actually be a shooting war between them remains to be seen. The main question on everyone's minds is, who would win if there was such a war? Both sides are extremely impressive on paper, but what they bring to the fight varies in quality. What kind of short-range and long-range weapons do they possess? Whose snipers are deadlier, and what are they armed with? How do both countries' main battle tanks stack up against each other? What about air force and naval power, and more non-traditional ways of fighting, like cyber warfare? And of course, we can't overlook the ultimate game-changer, nuclear capabilities. Who has the edge when it comes to weapons, China or the United States? Let's dive in. More often than not, wars are not won by missiles or satellites. They are won by men on the ground who are willing to commit acts of extreme violence in order to bring victory for their side. Going into battle, you want your troops to be outfitted with the best weapons they can have. It's the same story now as it was with the Greek hoplites and Roman legionnaires. So what are the US and Chinese troops on the ground armed with? Starting with the US, the main battle rifle that the ground troops of the US Army and US Marine Corps are armed with is the M4A1 carbine. It should be noted that the US military is currently in the process of replacing the M4 with the Sig Sauer XM7, which boasts a lot of improvements over its predecessor but is being rolled out and tested slowly. So as of this video's production, the US military's main battle rifle is still the M4A1. But what sets the M4 apart as such a standout weapon? The M4 has been the US military's bread and butter for over 2 decades. Battle-tested in the streets of Iraq, the hills of Afghanistan, and many other countless places around the world, it's proved time and again to be reliable, accurate, and deadly. Shooting a 5.56mm round from a 30-round magazine, the M4 is a lightweight carbine that's gas-operated, air-cooled, and magazine-fed. Weighing in at 2.5 kilograms when fully loaded, it's light enough to be carried into combat with a full pack. But that's not all. It also features a selective fire rate and collapsible stock, with an effective firing range of 600 meters and a maximum cyclic fire rate of 970 rounds a minute. The M4 allows the shooter to be efficient and accurate in both short and long-range situations. While the M4 is a favorite among soldiers and Marines, it isn't without its problems. Since it uses the gases expelled from the previous round to put the next one into place, after a while it can overheat and jam or misfire. Not great in a combat situation. Soldiers also noted that the aluminium magazines can dent rather easily and not function properly. They also said that when fighting in places with lots of sand, aka Iraq, the M4 requires near constant cleaning and maintenance to stay in fighting shape. However, its next-generation variant, the M4A1, sought to build on its predecessor and features a fully automatic fire rate, a more constant trigger pull, steel or polymer magazines, and a heavier barrel for improved accuracy and durability. Turning our gaze to the PLA, what's their weapon of choice, and how does it stack up against the M4A1? Enter the QBZ-95, born from the shortcomings of its predecessors. In 1991, the Gulf War kicked off and was almost over as quickly as it started. Coalition forces from the United States and other countries absolutely demolished the Iraqi army of Saddam Hussein, many of whom had been using Chinese-made weapons. This defeat was so decisive that the Chinese generals in the PLA began to plan for their own future. Recognizing that their current battle rifles, the Type 68 and Type 56, were quickly becoming outdated, so they strove to create something new. Introduced in 1997, it is a gas-operated, rotating bolt assault rifle with a bullpup design, meaning that the clip is behind the trigger. Part of the unique design is the striker firing mechanism. This mechanism makes it so the hammer, firing pin, and bolt are all in one piece. While this allows for easier cleaning and maintenance, it's also brought on some mechanical problems with the rifle. The QBZ-95 weighs in at around 2.9 kilograms when fully loaded and also has a 30-round capacity magazine like the M4. It has an effective range of about 400 meters and shoots at a cyclic rate of 650 rounds per minute. With selective fire available, the QBZ-95 is a versatile rifle capable of handling any situation. The QBZ-95 also has a couple of variants, including a light machine gun and a carbine. The QBZ-95 shoots a round unique to the Chinese military with specifications listed at 5.8 by 42 millimeters. It allegedly has an advantage over traditional 5.56 ammunition because it has a greater energy output due to it being heavier than the 5.56. The 5.8 has 77 grains of gunpowder compared to 63 in the 5.56. China keeps this information about this ammunition pretty secret, so there aren't a ton of reports out there about it. Sounds a little scary, but on the other hand, China also has not fought a serious war since 1979, so the 5.8 by 42mm round has not undergone extensive testing in combat either. Some of the known disadvantages are clunky magazine insertion due to its bullpup design, and its selective fire switch is in an awkward position as well. Overall, the QBZ-95 is a capable and lethal battle rifle when in the right hands, but time will tell how well it fares in the prolonged heat of battle. When comparing these two, it's quite difficult, as we do not have the same level of technical information about the QBZ-95 as we do the M4, nor do we have years of battlefield experience to look to.
will give the edge to the M4 here with its slightly better range, fire rate, and tried-and-true field experience. Moving a little higher up the food chain, we have light machine guns. As mentioned when discussing the M4, the US military is in a transition period when it comes to its squad-level firearms. The M249 squad automatic weapon is slowly being phased out in favor of the new XM250 from Sig Sauer. Since it's not yet in widespread use, we'll focus on the workhorse of the US military, the M249. The M249 Squad Automatic Weapon, or SAW, is a gas-operated, portable, belt-fed machine gun that fires the standard NATO round of 5.56. The operator can engage targets out to 800 meters and comes equipped with either 30-round magazines or 200-round boxes of belt-fed rounds. With a fire rate of up to 800 rounds a minute, the SAW comes equipped with a quick change feature for the barrel. This allows the gunner to keep a solid rate of fire without having to wait for the barrel to cool down. Seeing extensive use in Iraq and Afghanistan, the SAW has rained down typhoons of lead on insurgents for decades now. While it certainly has positives and performed well on the battlefield, it also has shortcomings. Troops often found the SAW heavy and clunky when maneuvering in combat. At 41 inches in length and 22 pounds when fully loaded, the SAW can become cumbersome during firefights or over long stretches of movement. In addition to this, there have been some concerns as to the accuracy of the SAW at extended ranges past 500 yards. Because of this, the US Marine Corps has replaced the SAW with the M27 Infantry Automatic Rifle, IAR, which is magazine-fed and shoots the same caliber as the SAW but has a much better accuracy and is lighter to carry. Another complaint about the SAW was that its 5.56 round was becoming outdated with continuing innovations in body armor technology. As body armor gets tougher, the 5.56 isn't as powerful as it used to be. This issue is being fixed with the next generation light machine gun the Army is rolling out, the Sig Sauer XM250. The XM250 shoots a .277 Fury, which is smaller in size to a 7.62 round, guaranteed to pack a bigger punch than the 5.56. So as the US military shifts away from the SAW, they will see some major advantages on the battlefields of the future. Switching gears and looking at the Chinese version, the QJS-161. Lightweight, accurate, and versatile, the 161 is a great light machine gun. Introduced in 2022 and steadily rolled out to the PLA troops, the QJS-161 is gas-operated and utilizes an open-bolt design. It shoots the Chinese-made 5.8x42mm round, the same as the QBZ-95, but the rounds are carried in a fabric container, which helps keep the overall weight down considerably. The fabric container is also an improvement over older models' drum magazines, which were heavier and more prone to jam. When empty, the 161 weighs in at only 11 pounds. This lightweight design is a considerable advantage over the SAW. There's not much data on the performance and ballistics of this gun yet, due to it being fairly new and the Chinese tendency towards secrecy in matters such as this. Overall, we'll give the advantage here to the 161, as it's much more lightweight and maneuverable than the SAW, although it seems pretty clear that in the near future, the M27 and XM250 might become equal or even surpass it. Now, any ground force needs both short-range and long-range weapons. Snipers have become a key asset on modern battlefields, both for the damage they can cause the enemy physically and psychologically, but also for their ability to gather intelligence. The US military uses a variety of rifles with its snipers, but we're going to focus on the Barrett Mk22 PSR, as it's currently in use by the United States Army and Marine Corps. This weapon comes with a lot of varieties in barrel length, weight, and even the caliber it can shoot. Weighing between 13 and 15 pounds, and with an overall length between 42 and 49 inches, the rifle can be customized to meet the needs of the mission. In addition to this, the stock is collapsible and the suppression system is removable, making it even more compact when needed. This will be especially useful for airborne troops and special operators, as they will have a rifle ready for every type of combat environment. In addition to this, the bolt-action rifle can be adapted to fire a variety of calibers from its 10-round magazine, including the NATO standard 7.62, .300 Norma Magnum, .338 Norma Magnum, .300 Win Mag, and others. Its maximum effective range comes in just under a mile at 1,600 yards. While this rifle has undergone extensive testing by all branches that will use it, it's yet to see significant combat use. Nevertheless, the precise and deadly rifle will be a terror on the battlefields of the future for years to come. Looking at the PLA arsenal, their snipers are equipped with a few different sniper rifles, but one of their main ones is the CS-LR35, military designation QBU-202 and QBU-203. Weighing in between 14 and 16 pounds and between 47 and 51 inches in length, the CS-LR-35 is a superb example of a modern sniper rifle. There are multiple variants of this rifle with different modifications, and it can even shoot two different calibers, the 7.62 by 51mm NATO or 8.6 by 70mm .338 Lapua Magnum. With an effective range between 1,300 and 1,600 yards depending on the caliber and a folding stock, the CS-LR-35 should more than cover the needs of an infantry platoon or special forces unit. Like its US counterpart, the CS-LR-35 is fairly new and has yet to see any combat, so given this and the similarities between the two, we'll call it a tie. Moving up the food chain of death and destruction again, we find ourselves at anti-tank weapons. Anti-tank weapons have been around since there were tanks to shoot at. Beginning in World War I, people needed a way to knock out the armored behemoths prowling the battlefield and used whatever was at their disposal, and that usually meant grenades or some kind of improvised explosive device. From World War II onward, we saw shoulder-mounted rocket launchers being used against tanks, and since that shift, the strategy has been much the same. Modern militaries today utilize both guided and unguided anti-tank rockets. For our purposes, we're going to look at the guided rockets as they're more advanced. Let's first take a look at one of Uncle Sam's most effective inventions, the feared and respected Javelin. The FGM-148 Javelin, or Advanced Anti-Tank Weapons System Medium, AWSEM, is an American-made man-portable anti-tank system. It was first produced in 1996 and has seen extensive combat in the global war on terror. In recent years, it has been on the front lines with Ukrainian forces as they battle back against Russian armor. It's been a key asset for them as it's helped knock out countless Russian tanks and armored vehicles. It is what they call a fire-and-forget launcher, as after the operator fires the rocket, they do not have to do anything else for it to strike the target. The rocket will lock on and guide itself there. The warhead itself is a high-explosive anti-tank warhead, or HEAT, and is capable of taking down modern armor using a top-down attack, meaning that the warhead strikes the tank where the armor is typically the thinnest, on the top. It can also be used to take out buildings or other fortifications using a frontal attack. The Javelin, when ready to fire, weighs about 50 pounds, so it's not something you can just casually carry around in the middle of a firefight. You have to move with a purpose. Able to be fired by just one person, it's an extremely valuable tool when it comes to anti-armor. Just talk to some of the Ukrainian soldiers. It has an incredibly impressive range of fire, with 2,500 meters being the standard, but under favorable conditions, it's even been successfully tested at a range of 4,700 meters. Now, while this is extremely impressive, it's not a given that this could be achieved in combat. Either way, it's a formidable weapon that will be used on many battlefields around the world. Looking at what the PLA has to offer, they have what is essentially a copy of the Javelin. Developed in 2014 and distributed to PLA units in 2021, the HJ-12 is basically just a Chinese-made version of the Javelin. It's capable of all the same things, is operated the same as well, and even weighs the same. In terms of range, they are very similar too. The only real difference comes with the diameter of the tube itself. The Javelin has a diameter of 114mm and the HJ-12 has a diameter of 135mm. This means that the HJ-12 is likely to be able to fire a heavier warhead capable of greater destructive power. For that reason alone, we'll give the advantage here to the HJ-12. While squad-level weapons are great in a firefight and often can handle whatever is thrown at them, sometimes you need to bring in a heavyweight fighter, that being armor. Tanks have been around in some form or another since the early 20th century, seeing their first combat use in World War I. The main US battle tank is the M1 Abrams, and it's seen combat consistently since the 90s. Even now, shipments of Abrams tanks are being sent to the besieged Ukrainian forces. The Abrams is 26 feet long, not counting the gun barrel, and has a width of 12 feet. The Abrams is one of the heaviest tanks in service, weighing over 70 tons. It boasts a variety of features that make it the incredible fighting machine it is, including a multi-fuel turbine engine, Cobham composite armor with upgraded models even having depleted uranium, a computer-controlled fire system, as well as multiple improvements for crew safety. In terms of weaponry, the later models are now equipped with a 105mm cannon and multiple 50 caliber machine guns. The cannon has an effective range of between 3,000 and 4,000 meters. The depleted uranium being added to the later models drastically increased the overall weight of the tank, as well as also increasing the protection. Additional upgrades over the years have seen reactive armor added as well. The Type 99 is very similar to the Abrams.
It's 3 feet shorter at 23 feet and lighter, weighing in around 64 tons. Being smaller and lighter might be seen as a disadvantage, but this means that they are able to be faster and more agile. The Type 99 is faster than the Abrams with a top speed of 50 miles per hour compared to the Abrams 42. It's also more fuel efficient, able to go about 311 miles before needing to refuel. The Abrams can only go 265. In terms of armor composition, the Chinese guard this secret very closely, so little is known. Although it is thought that the Type 99 armor is similar to the Abrams in general, it's also thought to have an advanced explosive armor system as well. Explosive armor systems are key to combating advanced anti-tank and armor-piercing missiles. In terms of armament, the Type 99 has the ZPT-98 cannon, which is similar to a Russian design and comes in at 125 mm. It has an effective range of about 3,000 meters. Both tanks can fire a variety of shells from high explosives and armor-piercing rounds to anti-personnel rounds. The Abrams also has something the Type 99 does not: a fourth crew member. This crew member's job is to load the shells. This is done by an autoloader on the Type 99. As it currently stands, the autoloader can load and fire 8 shells a minute. A human in similar conditions has the potential to be faster. So, looking at the Abrams and Type 99, they are both incredibly impressive tanks, but we have to give the edge to the Abrams here. Not only has it proved its efficiency in combat for 20 years, but it also has the edge when it comes to range and fire rate. If we knew more about the Type 99, we may change our answer, but until more is revealed or we see them go head-to-head, the Abrams is the winner, although it's close. Shifting gears and going up to the sky, let's look at air power. The Lockheed Martin F-35 Lightning II is a 5th-generation aircraft and is incredibly impressive and versatile. Since being developed in 2006 and slowly rolled out to the US military, it's become one of the most expensive aircraft on Earth. The F-35 features unmatched stealth, sensor fusion, the most powerful engine out there for fighters, and the most advanced radar system in the world. The pilots are even being equipped with an augmented reality helmet that improves their awareness and effectiveness in combat. I think it's safe to say we're close to Star Wars level weapons here. The F-35 has a wingspan of 35 feet, a length of 51 feet, and a maximum speed of about 1,200 miles per hour, or Mach 1.6. Its single Pratt & Whitney F135 PW100 engine also boasts a thrust of 40,000 pounds and an afterburner for supersonic flight and quick acceleration. The F-35 has a combat range of about 1,380 miles and a ceiling of 55,000 feet. In terms of weapons, the F-35 can support a payload of up to 18,000 pounds. If it's in the configuration known as Beast Mode, yes, it's really called that, the F-35 can support up to 22,000 pounds of payload. It has a 25mm cannon, as well as up to 6 missiles, 8 bombs, and 4 laser-guided bombs. Not too shabby. The Chinese counterpart is also a 5th-generation aircraft and is known as the Chengdu J-20. This was the first Chinese aircraft that was put on public display when it was unveiled, although like everything else, the Chinese are very secretive about its specifics. What we do know is that it's a twin-engine aircraft with 2 Shenyang WS turbofans and also has an afterburner. Its top speed is around Mach 2.25 or 1,725 miles per hour, which makes it much faster than the F-35. It also has a combat range of about 1,100 miles and a ceiling of 66,000 feet. For weapons, the J-20 features a similar loadout in terms of precision-guided munitions, but the real difference is that the J-20 does not have a cannon like the F-35. That means that if the J-20 were to get into a dogfight, all it would have is air-to-air missiles. So who would win if such a dogfight were to happen? The answer is clear, it's the F-35. The F-35 has better stealth capabilities, and while the J-20 is faster, the F-35 has a smaller radar cross-section, which means it's less detectable. So the F-35 could be locked on and ready to fire before you even know they're there. Another major disadvantage for the J-20 is the lack of cannon we just mentioned, so the F-35 has the advantage in dogfights. Even though it seems like the F-35 has the technical edge, it very well could come down to the skill of the 2 pilots. Diving into naval forces, let's take a look at who has better destroyer-class ships in the US Navy or the Navy of the People's Liberation Army. A major undertaking by the US Navy in recent years was building 3 of the Zumwalt-class destroyers. These next-generation destroyers are among the most advanced the Navy has to offer, with state-of-the-art stealth systems that allow it to move like a ghost through the water, as well as a brand new propulsion system and wave-piercing tumble-home hull.
According to the US Navy, the Zumwalt-class destroyers are the largest and most technologically advanced surface combatants in the world. Built by Bath Iron Works, it features an integrated power system of 2 Rolls-Royce MT-30 gas turbines with 2 auxiliary generators. It's over 600 feet in length and has a displacement of about 16,000 metric tons. It can reach speeds of over 30 knots and has a crew of about 200. In terms of weapons, it has 2 30mm gun systems, 2 155mm advanced gun systems, and 80 vertical launch cells for a variety of missiles. It's capable of many different offensive and defensive capabilities, including long-range precision strike, anti-air warfare (AAW), anti-submarine warfare (ASW), and anti-surface warfare (ASUW). It even has the capability to launch an MH-60R helicopter. It should be noted that for the 155mm advanced gun systems, the rounds are extremely expensive, about $1 million apiece, and the Navy really has no interest in getting any more than it already has, so these guns are somewhat outdated already. All in all, the Zumwalt-class destroyers are extremely impressive, but how do they stand up to the PLA Navy? The closest thing to it is the Type 055 destroyer. The Type 055 is about 590 feet long and 60 feet wide. With a full load, it has a displacement between 13,000 and 14,000 tons. The Type 055 has 4 QC-280 gas turbines, each providing about 23 to 28 megawatts of energy. The design is fairly conventional, with some exposed guns and sensors. This is the opposite of the Zumwalt. Everything is enclosed, however, the Type 055 is superior in its radar technology. The Type 055 has 112 vertical launch cells, firing a variety of missiles and torpedoes. It also features a 130mm gun on the bow, as well as several other close-in weapon systems for a last line of defense. Overall, the two ships are similar, but will have different missions. The Type 055 will focus on air and sea defense, while the Zumwalts will be focused more on targets on land and firing from close to the shore. So while they might be similar in some respects, they are for different purposes, and we cannot give a clear edge to one or the other. Turning from traditional weapons and looking at something more unconventional, and something that always seems to be in the news, cyber warfare. Obviously, we don't have a ton of information about what all goes into the cyber warfare departments or what they're capable of. They'd be pretty bad at their jobs if you could just read that info online. The US Cyber Command was founded in 2010 and seeks to unify the direction of cyberspace operations while continuing to bolster the Department of Defense's cyber capabilities overall. Its mission statement reads, US Cybercom plans, coordinates, integrates, synchronizes, and conducts activities to direct the operations and defense of specified Department of Defense information networks, and prepare to, and when directed, conduct full-spectrum military cyberspace operations in order to enable actions in all domains, ensure US allied freedom of action in cyberspace, and deny the same to our adversaries. Since 2015, the US has added an additional 133 new cyber teams to its arsenal. These include 13 national mission teams to defend against broad cyber attacks, 68 cyber protection teams to defend priority DoD networks and systems against priority threats, 27 combat mission teams to provide integrated cyberspace attacks in support of operational plans and contingency operations, 25 cyber support teams to provide analytic and planning support to the national mission and combat mission teams. Estimates of how many personnel are in Cyber Command range from 6,000 to 20,000. The mission of Cyber Command is to operate both offensively and defensively across the globe, combating malicious actors, counter ransomware attacks, and provide support to the DoD. How do the Chinese stack up in the new front lines of the cyber landscape? Again, everyone is incredibly secretive when it comes to cyber, but what we do know is that the Chinese have multiple units or groups actively engaging in cyber warfare at any given time. Some of these units are within the PLA, some within the government, and other various ones. It was estimated in 2017 that they had between 50 and 100,000 personnel designated as hackers, but who knows whether this is true or not. The Chinese military described their objectives in terms of cyber warfare capabilities as follows: cyberspace situational awareness, cyber defense, support for the country's endeavors in cyberspace, and participation in international cyber cooperation. Who has the advantage? Unless you have top-secret security clearance, I don't think any of us can truly answer that question. So as things continue to unfold, we'll just call this one a draw as well. Last but certainly not least, let's look at the biggest, baddest, and most horrifying weapons of all: nuclear.
The US nuclear capabilities on land consist of about 450 launch sites capable of firing the Minuteman III ICBMs, with 14 nuclear-capable submarines and over 60 nuclear-capable heavy bombers. Since tensions with Russia and China continue to climb, the US military is working toward modernizing and upgrading its nuclear defense systems. Overall, it's estimated that the US has about 5,000 warheads in total. For reference, a Minuteman III ICBM is about 60 feet in length, weighs 80,000 pounds, and has a range of 8,700 miles. They're each armed with 3 W62 Mark 12 warheads that each contain over 170 kilotons of TNT. The Chinese nuclear arsenal is estimated by the Pentagon to contain between 400 to 500 warheads, possibly reaching over 1,000 by 2030. Not much information about Chinese capabilities is publicly available, so we can only speculate. Who gets the advantage? It doesn't really matter after the first one detonates. Whether you have 20 or 20,000, it's all downhill after that initial boom. In conclusion, the militaries of the United States and China are extremely technologically advanced, well-trained, and deadly. So who has the edge overall? You can compare them and argue this point or that, but at the end of the day, none of it matters until the troops and equipment meet on the battlefield. Both sides have incredibly impressive troops and hardware, but the US is the only one with recent combat experience, so if any theoretical advantage is to be had, it would be that. Either way, let's just hope that the US and PLA troops never actually meet on the battlefield. A conflict between these two global superpowers would bring about nothing but widespread death and destruction to millions. No one wants that, except maybe the ones selling the weapons. So as tensions continue to escalate, just remembering how many nukes there are in the world might help everyone take a deep breath.